In this comprehensive generative AI course, you'll dive deep into the world of generative AI, exploring key concepts such as large language models, data preprocessing, and advanced techniques like fine-tuning and RAG. Through hands-on projects with tools like Hugging Face, OpenAI, and LangChain, you'll build real-world applications, from text summarization to custom chatbots. By the end, you'll have mastered AI pipelines, vector databases, and deployment techniques using platforms like Google Cloud Vertex AI and AWS Bedrock. Bakhtiar Ahmed Bapi created this course.
Generative AI is the most dependable skills nowadays across industries. If you see, all the industries have started using generative AI in their product development. If you want to level up your skill and if you want to crack good job nowadays with a good package, definitely you should know about generative AI. If you are looking for well-organized end-to-end complete generative AI course, I have a very much good news for you. Recently, I have published one amazing end-to-end generative AI course. So here I have covered everything you need to know to master the generative AI. This course will cover basics to advanced concept of generative AI. So here we are not only going to focus on the theoretical part, we'll be also focusing on the practical implementation of generative AI. We'll be exploring different kinds of large language model. With that, we'll be creating different kinds of generative AI based application. So let me show you the course content of this course. So guys, as you can see, this is the course content. As I already told you, we'll be starting from very basics of the generative AI and we'll be covering till advanced part of the generative AI. So here we'll be starting from introduction of the generative AI. So if you're completely new to this field, no need to worry. I'll cover each and everything you need to know about generative AI. Then we'll be learning about data preprocessing and embedding, because going forward, whenever you will be using large language model, and to give your data to the large language model, first of all, you have to know how to process this data and how to generate the embeddings of the data. And to process our data, we need to know some of the techniques. So here we'll be covering these are the technique in this section. Then we'll be starting with the large language model. We'll be learning about different kinds of large language model. We'll be learning about commercial large language model. We'll be also learning about open source large language model. We'll be starting with the Hugging Face platform and its API, because if you see the Hugging Face is having all kinds of large language model. Whether it's a commercial model, whether it's an open source model, all kinds of model are available inside the Hugging Face platform. Then we'll be also learning about OpenAI and its platform, because if you see nowadays OpenAI is evolving a lot. They are coming up with different kinds of large language model, like they are coming up with image model, language model, okay, different kinds of model they are bringing. So in this course, we'll be learning about the complete OpenAI and its platform so that you can use OpenAI platform to implement any kinds of generative AI based application. We'll be learning about prompt engineering, because if you see, prompt is everything for the large language model. So if you are designing a good prompt, definitely you will be getting a good response from the large language model. So here we'll be learning how we can design an efficient prompt, and we'll be also learning about different kinds of prompting inside large language model. In this course, we'll be mastering the vector database. We'll be learning different kinds of vector database like Pinecone, Weaviate, ChromaDB, FAISS, and so on. This vector database will help you to create a knowledge base. So whenever you will be creating any kinds of RAG based application, any kinds of LLM powered application, this vector database concept will help you a lot. In this course, we'll be mastering different kinds of generative AI based framework, like we'll be mastering LangChain, LlamaIndex, Chainlit, and so on. These are the framework will help you to implement different kinds of Gen AI based application. In this course, we'll also learn one very important topic inside generative AI called retrieval augmented generation, that means RAG. So we'll be learning how we can create different kinds of RAG based application with our custom data. Even we'll be also learning how we can fine tune any kinds of large language model on top of our custom data. After completing all the topics inside generative AI, we'll be starting with some end-to-end project implementation with the deployment. So here we'll be implementing this kinds of project from scratch. We'll be using modular coding to implement this kinds of project. At the last of the course, we'll be also discussing about LLM ops. If you see inside generative AI, LLM ops is the most trending topic nowadays. We'll be learning how we can use different kinds of LLM ops platform, like we'll be learning about Bedrock, Vertex AI, and we'll be learning how we can use these are the platform to implement efficient large language based application. So yes, this is the complete curriculum of our course. So if you want to start your career with generative AI, guys, so this would be the amazing course for you. So make sure you complete this course till the end. And this is my promise, guys, you will become champion inside generative AI. With that, guys, all the best, and I will see you in the course. Hi everyone, welcome to the course of Generative AI. My name is Bakhtiar Ahmed Bapi and I am a data scientist and mentor. I am having more than 4 years of working experience in the field of machine learning, deep learning, generative AI, ML ops, and so on. I have already worked with so many multinational companies as a developer. Even I also work with so many edtech company as a mentor. I have also taken lots of batch related generative AI, machine learning, deep learning, computer vision, natural language processing, and so on. So throughout the entire course, I'm going to be your mentor. So as I already have some experience from the industry, so in this particular course, I'm going to share my knowledge and experience with you. So in this course, we'll be starting with the very basics concept of generative AI and we'll be completing till advanced part of the generative AI. So if you're a beginner, if you want to start your career with the generative AI, so this course is for you. I have designed this particular course in such a way so that anyone is coming from any kinds of domain, they will be also able to understand. So if you're from non-tech background, if you're from tech background, it doesn't matter. So if you're interested in generative AI, only you just need to start with this course. Everything I will take care. Apart from the theoretical understanding, I'm also going to show you lots of practical in this particular course. We'll be doing lots of hands-on in this particular course. We'll be solving different problem statement in this course so that your understanding would be more clear. Hello everyone, welcome back with another video. In this video, we'll be discussing about what is generative AI. So before discussing about generative AI, first of all, let me introduce some of the real world application of the generative AI you are using in your day-to-day life. So I think you know about ChatGPT, Google Gemini, Meta Llama, right? So these are the application you are using in your day-to-day life. I hope everyone has used ChatGPT at least, right? So inside ChatGPT, what we can perform, we can give any kinds of prompt. We can do the conversation. We can do the summarization. We can generate the content. We can generate the code. We can do the text summarization. Any kinds of task we can perform in the ChatGPT, right? So similar wise, Google has developed their own product called Gemini. Okay, Google Gemini. So with the help of Google Gemini, also we can perform the same things. The things actually we perform usually in our ChatGPT. So the same thing we can perform with the help of Meta Llama 2 as well. That means ChatGPT is developed by OpenAI, Google Gemini is developed by Google, and Llama is developed by Meta. Okay, Meta AI, that means Facebook. So all the tech giants companies are working on generative AI. Day by day, they are improving this particular generative AI. They are bringing actually different large language model, and they are launching different application. Okay, for the users. Nowadays, all the companies are using generative AI to implement their product. So currently in the market, generative AI having more popularity. So that's why you have to know what is generative AI exactly, how generative AI works. And definitely if you want to work in the current job market, you have to know about this generative AI. You have to learn about this generative AI. Okay, this is the idea. See, all the application I showed you here like ChatGPT, Google Gemini, Meta Llama. So they are using something called large language model in the backend. Okay, with the help of large language model, they are able to perform. These are the operation. Now, first of all, let's try to understand what is generative AI exactly. See, generative AI is nothing but generative AI generates new data based on training samples. Generative model can generate image, text, audio, video, and so on data as an output. So I think you have already worked with machine learning, deep learning, computer vision, and so on, right? So there you used to use something called discriminative model. And what is discriminative model? Based on some input, actually, it will predict the output of that particular data. Okay, so this was actually discriminative model. And to train the discriminative model, actually, we used to use something called label data. That means whenever we used to prepare the data for the training, we used to prepare the, let's say, input data as well as the output data. That means you have to pass the X data and Y data. That means input and output both. Okay. And if you give input and output both, it will learn the relationship between input and output. It will learn the pattern from the data. Then it will able to predict something on top of the test data. So that was the idea in the discriminative model. That means in the prediction model, right? But generative models are different. Okay. So generative models can generate a new data based on the training samples. So here you will be giving some training sample, which is called unstructured data. So based on this training sample data, it will try to generate some new data. That means inside Gen AI, whenever you are giving any kinds of unstructured data as an input, your generative model will try to understand this unstructured data. It will learn the pattern from the unstructured data, and it will try to generate something from that particular sample you are giving. Okay, this is the idea. And output can be anything. It can be text, it can be audios, it can be videos, and so on. Okay, as I already told you, inside generative AI, we not only work with the text, but also we also work with the image, videos, audios, and so on. Okay, so all the unstructured data can be used inside generative AI. This is the idea. So that's why I've written generative AI is a very huge topic. Inside generative AI, actually, we are having generative image model as well as the generative language model. That means you can work with the languages, that means text. You can also work with the images, videos, okay, and audios. So there is another model you can consider, generative audio model. But at the end, you are converting this audio to the text representation, that means language representation. That's why I haven't mentioned this audio model separately. Okay, this is the idea, because audio is nothing but it's a frequency, and from the frequency we can convert to the textual representation. Okay, this is the idea. There are so many API you will get. Even Google has the API. You can let's say convert speech to text. Okay, with the help of speech to text, you can easily convert any kinds of audio to textual representation. Okay, this is the idea. That means what is generative AI? Generative AI is nothing but it generates new data based on the training sample you are giving. And generative model can generate any kinds of output, whether it can be image, it can be text, or it can be audios. Okay, now let me tell you how they got the idea, like how the generative model can work. See, this idea had taken from real life only. Let's say if I give you 10 different cat book. Okay, let's say if I give you 10 different cats book, and if I tell you just try to read all the 10 different cat book. Let's say you have read all the 10 different cat books. Now if I'm asking anything related cats, okay, you will be able to give me the answer because you have already studied about the cats. Like 10 different books I have given, and this was the enough data for you, right, to learn about the cats. So that's why if I'm asking anything related to the cats, you will be able to give me the response. So here you have become one cat model. Okay, you have become one cat model, and that is why if I'm giving any kinds of question, you will be able to give me the response. Okay, so similar concept applied in the generative AI also. So they implemented one model called generative model. In the generative model, they feed actually tons of data. That means huge amount of data they trained, okay, that particular model. And then actually they were giving some kinds of question, and that particular model was able to give the response. Okay, this is the idea. That means here you are feeding tons of unstructured data, and your model is able to, let's say, learn the pattern from the unstructured data. And there would be a position, your model will be able to capable enough to give any kinds of response, okay, based on the question you are asking. Now you can ask me why generative models are required. See, I can give you thousands reasons of the generative model requirement, but here I have listed down some of them. So the first thing you can consider, understand the complex pattern from the data, because nowadays you can see people are using unstructured data a lot. Unstructured data means it can be text data, it can be audio data, it can be videos data, right? So this is called actually unstructured data. And in today's world, actually people are using internet broadly, and in internet actually people are generating huge amount of unstructured data. Okay, they are using different social media, they are using different platform. So that's how actually they're generating tons of unstructured data. So that's why it's very hard to understand the pattern from these kinds of unstructured data without traditional machine learning model. Okay, so that's why this generative model comes into picture. So it can easily understand the complex pattern from these kinds of unstructured data. The second thing you can consider the content generation. That means your generative model can generate any kinds of content. It can generate code, it can generate, let's say, any kinds of story, it can generate any kinds of music, any kinds of videos. Now I think nowadays you have seen like there are so many applications came in the market. So if you give any kinds of prompt, it will generate the video for you, okay, the complete video for you. That means it is generating some content. Okay, it is generating some content based on the prompt you are giving. And that's how for the content creator also, it is becoming one of the very used tool, okay, for their content generation and all. Let's say you are a blog writer. Now you don't need to write the blog from scratch. So what you can do, you can just pass the topic and your model will generate the blog for you. And what you can do, you can just modify this particular blog with respect to your requirement, and you can publish, okay, anywhere. You can also generate any kinds of videos. You can also generate any kinds of reels, okay. Everything is possible nowadays with the help of these generative models. Okay, so that is why content generation is one of the very important, let's say, features inside generative models. Okay, I can talk about. Now the third thing you can consider, build powerful application. As I already told you, we are already using tons of powerful application in our day-to-day life, like ChatGPT, Gemini, okay, then Llama. So different actually powerful application we are using in our day-to-day life. And just try to think about when we didn't have these kinds of application, we had to complete lots of work actually manually. But nowadays we are having this kinds of powerful application. Now you can do any kinds of work actually in a few seconds. Okay, it is possible. Let's say if I give you one example, as a developer, whenever let's say you are getting any kinds of error, okay, from your, let's say, application, what you can do? You can copy that error and you can ask through the ChatGPT. ChatGPT will give you the solution, okay, how we can solve it. But previously when we didn't have any kind of ChatGPT, what we used to do? We used to search that particular error inside Google. We used to open the Stack Overflow and we used to see lots of, let's say, solution. Then we used to solve that particular, let's say, error. And nowadays, actually, we are using this kinds of application and it is actually saving lots of our time. So we don't have to spend actually lots of time to fix any kinds of bugs. In a few seconds, actually, it is possible nowadays if we are using this kinds of powerful generative AI based application. Okay, this is the idea. Those who have already studied about artificial intelligence, machine learning, deep learning, maybe you have already seen this kinds of Venn diagram. Okay, this is the Venn diagram of our AI, the complete AI. Now you can see machine learning is a subset of artificial intelligence. Deep learning is the subset of machine learning. And now here you can see generative AI is the subset of deep learning. Okay, it is the subset of deep learning. That means machine learning is the subset of artificial intelligence. Deep learning is the subset of machine learning, and generative AI is the subset of deep learning. Okay, this is the complete Venn diagram of the complete artificial intelligence. Okay, I hope it is clear. Now let's try to see the difference between discriminative model and generative model. You can see discriminative model is nothing but it's just a prediction model. Let's say here you have given two input. One is the cat image, another is the dog image. What your discriminative model will do, it will try to predict whether it's a cat image or whether it's a dog image. That means you are trying to do some prediction here. I think you already use this kinds of model in your deep learning. Let's say whenever you used to perform something called image classification, there we had different model like ResNet 50, Inception V3, right? MobileNet, VGC16. So with the help of this particular model, we can perform the image classification task. On the other hand, generative model can take actually any kinds of sample data, any kinds of noise data, and from that particular noise data, it will generate a complete new image for you. Okay, new data for you. Now let's say here you are passing one noise data. Noise data means it can be any kinds of unstructured data. And what generative model will do, it will try to understand the pattern. Okay, it will try to understand the pattern from these kinds of data. Okay, then it will generate a new data for you, new data point for you. This is the idea. Okay, this is the idea of the generative model. See, I have kept another example here. Let's say, so here we are using discriminative model to classify the music type. You can see here we are giving actually different music, rock, classical, and romantic. So here your discriminative model, that means your discriminator deep learning model will try to classify whether it's a rock music, whether it's a classical music, or whether it's a romantic music. On the other hand, generative model, what it will do, you will just give some music sample, okay, and generative model will try to understand the pattern. It will generate a complete new music for you. Maybe you have already heard of AI has created music, AI has created songs, AI has written story. How? That's how actually they're using something called generative model. They're actually feeding lots of training samples, okay, and this model is learning and it is generating a new content, okay, with respect to the data they are giving. This is the idea of the generative model and the discriminative model. I hope now it is clear. Now if I discuss a little bit low level, like how things are working here. See, maybe you have heard of something called supervised learning. Okay, in supervised learning, what we do, we give the X data as well as the Y data. That means input and output. And here we try to find the relationship between our input and output. Okay, this is called actually supervised learning. And whatever actually, let's say, discrete model actually we're using, it is called actually supervised learning. On the other hand, we are having another learning called unsupervised learning. In the unsupervised learning, what we used to perform, we used to perform something called clustering technique. Let's say here we are only giving the X data, that means the input data. And what my model will try to do, it will try to make a cluster. Let's say this is one cluster, this is another cluster, this is another cluster. That's how it is separated out my data. Okay, that's how it will find out the relationship between the data. Okay, this is the idea. Now you can consider this unsupervised learning as a generative model. So generative model will also work in the same way. So instead of actually finding the relationship, what it will try to do, it will try to make a cluster. Okay, it will try to make a cluster from the unstructured data actually will be feeding. This is the actually low level actually understanding I'm giving you how things are working here. But on top of that, they have added some more technique to actually build these kinds of generative AI model. Okay, this is the idea. So in summary, actually you can see generative AI is a subset of deep learning, and generative models are trained on huge amount of data, as I already told you. While training the generative model, we don't need to provide any kinds of label data. We only give the unstructured input data, because whenever you are working with huge amount of data, it's not possible to label the data. Okay, that's why you are giving the unstructured data as an input to the generative model. So here you can see in generative AI, we give the unstructured data to the large language model for the training purpose. And whatever things I explained so far, you can see what your discriminative model will do. It will try to actually predict whether it's a dog image or whether it's a cat image. Okay, by finding the relationship. On the other hand, your generative model will try to make a cluster. Okay, let's say this is a cat cluster, this is a dog cluster. Okay, then with the help of that, it will able to generate a new content from you. I think you have heard of something called GAN, the generative adversarial neural network. Okay, so GAN is also called generative model. Okay, because here you will be giving noise data, and from the noise data itself, it will able to generate a new content. Okay, new data. This is the idea of the GANs. So far I told you about generative model, but what exactly this generative model? See, generative model is nothing but it's a large language model, which is also called LLM. See, a large language model is nothing but it's a foundational machine learning model that uses a deep learning algorithm to process and understand the natural language. These models are trained on massive amount of text data to learn patterns and entity relationships in a language. It can be also considered in a image data as well. Okay, not only text data, you can also use LLM for the image as well, because I told you we are having two kinds of model, generative language model, generative image model. Okay, so you can also use image data here, not only text data. And it is a language model which is responsible for performing tasks such as text to text generation, text to image generation, image to text generation. As I already told you, generative model can support actually all kinds of data. You can generate text to text, you can generate text to image, even you can also generate image to text. Okay, everything is possible with the help of this large language model nowadays. Okay, and we also call it as multi-model. That means you can perform multiple tasks here, not one specific task. You can perform multiple tasks like text to text, text to image, and image to text generation. Apart from that, you can perform some more tasks. Let's say you can perform language translation, you can perform text generation, you can perform, let's say, text classification, you can perform sentiment analysis, name entity recognition, all kinds of tasks you can perform with the help of only one model, and which is nothing but our large language model. Okay, and large language model is nothing but our generative model. Okay, this is the complete idea about our generative AI. I hope it is clear now. Now let's try to understand what makes LLM so powerful. As I already told you, in case of LLM, one model can be used for whole variety of the task. Okay, I told you now, text generation you can perform, chatbot you can perform, summarization you can perform, translation you can perform, code generation you can perform. That means whatever task actually you have inside the NLP, all the tasks you can perform with the help of one model, which is nothing but large language model. So that's why we call this LLM is so powerful, and that makes LLM so powerful, because in our traditional model, whatever model we used to use, that means the language model only, we can only perform one specific task. Let's say you want to do actually language translation. For language translation, you need to only train one language translation model. That model can't do the code generation, or let's say text summarization. That model can't perform. But if you're using large language model, you can perform all kinds of tasks with the help of one model only. Okay, so that's why LLM is so powerful, because of this particular idea. So as I already told you, if you're using your traditional actually language model, it can only perform one specific task at a time. Let's say you want to build a sentiment analysis. So one model you have to train for the sentiment analysis, which will only able to do the sentiment analysis, whether this particular, let's say, sentiment is positive, neutral, or negative. Let's say you want to perform language translation. You have to train another model for the language translation, and that model will be able to translate any kinds of text. Okay, that means you have created two separate model, okay, for two separate tasks. But if you are using large language model, you need to only train one specific model, okay, and that can perform multiple tasks. This is the idea of large language model. So let's see some of the large language models. So here you can see we are having Gemini, GPT, XLM, then we are having T5, Llama, Mistral, Falcon. Apart from that, there are so many large language models are available over the internet. I'm going to discuss, I'm going to show you each and everything. So here I just mentioned some of the large language models just to show you. But I will tell you how you can see all the large language models are available over the internet. Even I will also show you how you can access those models and how you can use those models to create your application. Okay, on top of it, everything I'll try to clarify. So yes, guys, this is the introduction of generative AI. Now I think you got the clear-cut idea about generative AI, like what exactly is generative AI, and inside generative AI actually what are the things are available, and why it is actually mostly used technology inside any kinds of software product nowadays. And inside generative models actually what is uses, it is uses something called large language model. And not to worry, I'll discuss about large language model in detail, like how large language model works, and inside that what are the architecture they're using, everything I will try to clarify. And now you can ask me what is end-to-end pipeline of generative AI. No need to worry, I will explain each and everything, what is pipeline and all, and why pipeline is super important whenever you are working in the generative AI field. See, it's not like that whenever you are getting some problem statement from your company, whenever let's say you are receiving the data, it's not like that you will be directly applying the model on top of it. Before applying the model, we have to perform some specific task, okay? And those step-by-step task is called pipeline. So you can see generative AI pipeline is a set of steps followed to build an end-to-end GenAI software. Okay, that means here you will be breaking the problem statement into several sub-problems. Then you will be trying to develop a step-by-step procedure to solve them. And here you can see, since language processing is involved, okay, inside generative AI, so we would also list all the forms of text processing needed at each step. This step-by-step processing of the text is known as a pipeline. Okay, that means that means whenever you are getting any kinds of problem statement from the company, first of all, break that problem statement in a several sub problems. Okay, then try to solve one by one. And to solve that, you have to perform some steps. Okay, you have to perform some steps, and those steps is called actually pipelines. Okay, pipelines inside generative AI. Now let's see one end-to-end pipelines actually we have to follow for all the projects we'll be developing in futures. See, in generative AI pipeline, we are having, these are the steps we have to follow. The first step actually we have to follow the data acquisition, because here data is everything, right? At the end, you have to work with the data here. So first of all, you have to get the data, and these steps falls into data acquisition part. Okay, then after that data acquisition, we have to perform something called data preparation. Okay, what is data preparation? I will let you know. That means here you will be doing the cleaning of your data. Okay, after that you will be starting with something called feature engineering. Inside feature engineering, there are so many steps you can follow. Like, so the main step actually you'll be doing inside feature engineering called text representation. That means you will represent your text to the vector, that means number, so that your model can take the input. Then after that you'll be doing the modeling. Then you have to select different model and you have to feed the data there. Okay, this is the idea. After modeling, what you have to do, you have to evaluate that particular model, because unless and until you are not evaluating the model on top of test data, you won't be able to decide whether this particular model is suitable for our production or not. Okay, then once, let's say you got your let's say production model, what you can do, you can do the deployment of your model. You can host your model so that other people can use your model. Okay, other user can use your model and they can give the feedback. Okay, based on the feedback, last step what you can do, you can perform monitoring and model updating. That means you have to monitor, you have to keep on monitoring your application. Like I think you saw the ChatGPT, right? So previously I think you saw in ChatGPT, whenever let's say you are giving any kinds of prompt, so it will give you one actually, let's say input form. It will tell you, are you enjoying this ChatGPT, or any kinds of feedback you want to give or not. So there actually they were taking the input in real time. Okay, this is called actually monitoring. Okay, monitoring their application. That means they're monitoring whether this application is working fine or not in the production. If something going wrong in the application, if let's say user is giving negative feedback, that time what they will do, they will try to update this model again. Okay, this is the idea. So it's not like that you are only building your model, you are only deploying your model. It's not like that. You have to monitor the model in production, and based on the feedback you have to keep on updating the model itself. Okay, this is the complete idea, and these are the steps involved inside the generative AI pipeline. I hope it is clear. Now let's break down all the, let's say, pipeline steps one by one and try to understand what we have to do in each and every step. The first step was actually data acquisition. So inside data acquisition, you can follow some step to collect your data. So the first thing you have to check whether you have available data or not. So available data. Available data means, let's say you are having a CSV file directly, you are having, let's say, text file, you are having, let's say, PDF documents, you are having docs documents. Then you might also have something called Excel SX. Okay. So if you have, these are the files. Apart from, if you have any other file format, it's completely fine. But first of all, you have to check whether you have available data or not. Okay, this is the idea. Now, if you don't have the available data, what you have to do, you have to look for other data. Okay, other data. Other data means you can collect the data from the database. You can see in the internet whether someone is having the data set or not. Then you can also use the API. Let's say someone will give you the data, but you have to fetch the data through the API. That time actually what you can do, you can collect the data from the API itself. Okay. Then you can perform something called scraping. That means web scraping. Let's say you don't have the data in database, internet, API. Then what you can do, you can do the web scraping. Okay, web scraping means you will be scraping the data from a website. Okay, this is the idea. Now there is another possibility, you have no data. That time what you will do? Okay, that time what you will do? That time you have to create your own data. Create your own data means either you can collect the data. Okay, either you can do the survey, you can collect the data, or what you can do, you can use large language model to generate the data. Okay, LLM to generate data. Nowadays actually you will see people are using OpenAI. Okay, OpenAI GPT model. Okay, GPT model to generate the data. Okay, so with the help of LLM also you can generate your own data. But whenever you are creating your own data, there is a possibility, let's say your data will be less. Let's say here I will just write, you have to note let's say whenever you are collecting your own data, your data quantity might be less. So that time what you can do, so let me write here, if you have less data, then you can perform data augmentation. I think you know what is data augmentation. Okay, so data augmentation is nothing but you will be augmenting the data. Let's say I'll give you one example. So the first augmentation technique you can perform, so let me give you the example. You can do something called replace. You can do replace with synonyms. Okay, now how to do the synonyms? See, let's say here is one example I will give you. Let's say I am a data scientist. Okay, so let's say this is my text. Now what you can do, you can just replace this synonyms. So here you can write I am a AI engineer. That means you are replacing this particular entity with this entity. So this is called actually replace with synonyms. Okay, this is the idea. I hope you got it. Because here you will be working with textual data mostly. And if you have the image, that time what you can perform. So there are lots of image augmentation technique as well. Let me show you. So you can simply search image augmentation. So there are different technique you can follow. See, let me show you one example. Let's say this is the example I can show you. Let's say this is your original image. So what you can do, you can do the horizontal flip, you can do the vertical flip, you can do the rotation of the image, you can also do the negative rotation, you can do the blur operation, you can change the brightness, you can add some noise, you can add some darker. Okay, so that's how actually you can change the original image. Okay, you can change the original image and make different variants. Okay, this is called actually image data augmentation. Because I already told you, inside GenAI we use both kinds of data, whether it can be textual data, it can be image data, it can be audio data. Okay, anything actually you can consider here. Now the next technique you can apply, which is called bigram flip. Bigram flip. Now you can ask me, sir, how to perform bigram flip? See, it's very easy. Let's say I'll give another example. I am Bappy. All right. Now you can write this sentence like that. Bappy is my name. Okay, so this is called actually bigram flip. That's how actually you can also do the data augmentation, because at the end you are increasing the data. That is the idea. And whenever you are increasing the data, it should have the meaning. It doesn't have the meaning, that means there is no use of the data. So you have to make sure whenever you are performing, these are the technique, this data should have some meaning. I hope you are getting my point. Now the next thing you can perform, third step you can perform, back translate. Back translate. Now how to perform back translate? Let me show you. So let me go to my translator. So I'll open the translator. Okay, Google Translator. Let's say here if I write one sentence, or I can just copy one story. Let's say here what I will do. Let's say I will copy this text, and here let me paste it. Now you can see it is translating to the Bengali. Now what I will do, I'll copy this Bengali translation, and here the input language I'll be selecting the Bengali right now. So let me select the Bengali and I can paste it here. Now here you can select any other language. Let's say I'll select Spanish. Now see, Spanish text it is giving. Now let me copy. Okay. Now what I can do again, I can come here, I can paste the Spanish text, and let's say I want to convert to English again. So here let me select the English. You got your English text. Now so here if you see carefully, some of the word would be different, okay, than your previous actually text you have copied after doing the bigram flip. That means you will be converting a language to another language, that language to another language, then again in your English language. So that's how if you do multiple time translation, you will see some word would be changed. And see, this will work if you have actually lots of text, actually lots of sentence, not like that you are only copied 1 to 2 line. If you have multiple, let's say line, multiple text, that time actually the reflection actually will able to see. Okay, I'm just only showing you how we can perform the back translation, because there are so many API nowadays inside Python you can use for the back translate. I think translation API is already there. With the help of that, you can do the translation. First of all, let's say you have the English text. First of all, try to translate to the Hindi to, let's say, Spanish to English again. That's how you can do the back translation and you can increase the data. So this is another amazing data augmentation technique you can follow. Okay, I hope you cleared. The last step actually you can follow something called add additional data or additional noise. How we can add additional noise? Let's say here you have one sentence, I am a data scientist. So with this sentence you can add one more line. Let's say I love this job. Okay, so this is your additional data or additional noise you have added, okay, with your data. So again, this is called actually data augmentation technique, and again it's an amazing technique you can follow, okay, altogether. So these are the steps actually you can perform inside data acquisition. Okay, so first of all, try to check whether you have available data or not. If you don't have, try to see the other data. If you don't have, try to create your own data. For this you can use large language model. Even I will also show you how we can generate your data with the help of large language model. And after generating, let's say if you have less amount of data, in that case you can perform something called data augmentation technique. Inside data augmentation technique, these are the steps you can perform. Okay, so this is the first step of the pipeline. Now let's discuss the second step of the pipeline. Okay, the second step, I think you remember, data pre-processing. So inside data pre-processing you can perform cleanup operation. Okay, cleanup operation. That means you can remove HTML tags, then you can remove, let's say, emoji. You can do the spelling check, okay, spelling correction. Fine. So these are the technique actually you can perform inside cleanup. Now there is another step you can follow called basic pre-processing. I'll tell you what are the basic pre-processing are available. Even I will also show you the practical how you can perform. Then you can also perform something called advanced pre-processing. Because nowadays the application actually we have, let's say, ChatGPT, Gemini. So these are the actually advanced application, advanced, let's say, large language model. So for this we have to also perform some advanced pre-processing technique. Okay, let's say whenever I'm having that data nowadays, because let me show you. Let's say if I open my ChatGPT, okay, if I open the ChatGPT, see if I give any kinds of emoji nowadays inside ChatGPT, still it will be able to understand. Let's say if I give this haha, okay, haha, let's say emoji. Now if I send it to my ChatGPT, see, it is automatically detecting what's so funny. Okay, so that's kinds of text also we need to handle, because whenever we are collecting the text data, it will have emojis, it will have HTML tags, okay, so many things it will have. So sometimes it is also necessary to keep the emojis, because I told you now, this kinds of application is advanced, so it is also understand the emojis, any kinds of text. So we also need to handle these are the, let's say, text in that time. Now inside basic pre-processing, let me just write here, inside basic pre-processing. So inside basic pre-processing, the very important things you have to perform something called tokenization. Okay, so you have two kinds of tokenization. One is called sentence level tokenization. Another one is word level tokenization. So I'll be discussing each and everything, no need to worry. And there are some optional pre-processing are available. So inside optional pre-processing, the first thing you can perform, stop word removal. Okay, stop word removal. Then the second things you can perform something called steaming. And this is like very less used nowadays. Okay, less used actually technique. The third thing you can perform something called lemmatization. And the lemmatization actually more used. Okay, I'll tell you what is steaming, lemmatization whenever I'll show the practical, that time I'll discuss. Then the fourth things you can perform something called punctuation removal. So punctuation means, let's say you have question symbol, you have dot, you have comma, you have exclamation sign, okay, you have dollar symbol. So these are the things are actually punctuation. So you have to also handle the punctuation. Then you have to perform something called lowercase. Then the sixth, you can perform something called language detection. Because nowadays, if you open the ChatGPT or Gemini, if you give any kinds of language, it will first of all detect in which language you are asking the question. Based on that, it will give you the reply, okay, in the same language. So so they are also applying this language detection technique, okay, in the backend. So that's actually one real world product implement. Okay, it's not like that you are getting the data, you are directly applying the model. It's not like that. So you have to follow the entire pipeline to build the end-to-end software. Okay, that's why I'm showing you these are the pipeline. Why this generative AI pipeline is super important, and what are the steps are involved, okay, inside the pipeline, so that after learning it, it would be easy for you to develop any kinds of software in future. And this is my promise. If you understand this, okay, if you can do this, you can design any kinds of software in future. Okay, because what is generative AI? Generative AI is nothing but just a technology. So you have to use that technology. You have to learn how to use the large language model, how to prepare the data for the large language model. Okay, how to use, let's say, a LangChain, how to use vector database. You have to connect everything together. Then you have to build one application. That is the idea only. But the root things available inside the pipeline, how you're designing the pipeline, whether pipeline has all the steps available or not. I hope you're getting my point, right? So now I think these are the steps are clear. But I think some of them still you are getting confused, like what is steaming, what is, let's say, lemmatization, what is, let's say, why we have to perform the lowercase operation, and what is this tokenization. See, let me just discuss all of them one by one. So first of all, let me discuss the tokenization. That means, let's say you are having a sentence here. Let's say my name is Bappi. So this is a sentence, right? This is a complete sentence, right? So whenever I will be converting this sentence to number, that means vector representation, first of all, I have to actually do the tokenization. Tokenization means you will be taking the individual words, let's say like that, my, comma, name, okay, comma, is, comma, Bappi. This is called actually word level tokenization. Okay, word level tokenization. Okay, that means you had one complete sentence, you just did the tokenization and you got the word as a token, okay, everywhere. Now you can take the word and you can convert to number. There are some technique we can follow. I'll tell you those are the technique, what are the technique you can follow to convert your text to number representation. Okay, and there is another technique called let's say sentence level tokenization. Let's say you are having a sentence like that. Let's say my name is Bappi. I am a data scientist. Okay, now if I perform sentence level tokenization, so sentence wise actually I have to convert. So it will come like that. My name is Bappi. So this is my one token, then comma, then I am a data scientist. Okay, this is another token. That means two token I'm having in the list. Okay, this is called actually sentence level tokenization. Sentence level tokenization. Okay, so we'll be using this word level tokenization a lot. Sentence level you can also use. Sometimes you have to use sentence level tokenization. Sometimes you'll be using word level tokenization. But most of the application I saw, people are using word level tokenization. That is the idea. So this is what actually our tokenization. Okay, now let's try to understand what is steaming. See, steaming is nothing but you are bringing one word in a root form. Let's say here we are having three kinds of word: play, played, and playing. So if you see them carefully, meaning are same, yes or no? Meaning are same, only the word representation is different. Now instead of taking actually three, okay, separately, what I can do, I can convert in a root form. So root form is nothing but play. Okay, because play represents sports. Okay, sports. So this is called actually steaming. That means you have different actually word form, that means different verb form, and you are trying to bring in a root representation. Okay, this is called actually steaming. And again, it's important because it will reduce the dimension. Okay, it will reduce the dimension whenever, let's say, you will be converting your data to the vector representation. Because if you have three word, so it will create actually three dimensions separately. But if you convert it to one, let's say word only, so it will only have one dimensional. And we know that inside artificial intelligence, dimension is like the issue. So if you have, let's say, more dimension, that time your model will get confused, because there is a concept of curse of dimensionality. So you have to also take care about the dimension. Okay, that's why we perform this steaming operation. And lemmatization is the same. Okay, the way actually perform the steaming, lemmatization is also same. Only whenever you will perform the lemmatization, your root meaning of the word would be readable. But whenever you will perform actually, let's say, steaming, sometimes it won't be readable. I'll tell you whenever I'll do the practical of it, that time actually we'll get it. Okay, what I'm trying to say. That is the idea. Now you can ask me what is lower casing, okay? Because punctuation you already know. Now you can ask me why lower casing is important. Why you have to perform the lowercase operation. Let's say if I write to sentence, Bappy is very good boy and Bappy is a data scientist. Let's say these kinds of sentence we are having. Now here you can see, I think Bappy and Bappy, both name are same, but here you can see the first character it's a capital one, the second character it's a lower one. So as a human, actually you can consider these two Bappy are same, but whenever you will be passing to the model, that means in your computer will be considering these two word is a different word, because here you are using capital and here you are using lowercase character, because all the character is having their ASCII value, right? That means the ASCII code, Unicode. So with the help of that, it will consider these two words are separate. So that time, this Bappy would be different, this Bappy would be different, although they are same. Okay, this is another issue. So that's why we perform lowercase operation. So whenever actually we're having the uppercase, we'll try to convert to the lowercase. Okay, we'll try to convert. So let me show you. We'll try to convert to the lowercase. Okay, so this is now you can see this Bappy and this Bappy will become same. Okay, now if you pass to the computer also, your computer will identify this Bappy and this Bappy is the same right now. Okay, so that's why we perform the lowercase operation, so that my model won't be getting the confused. Okay, this is the idea. So I think most of the things I clarified, and yeah, so everything I'll show you as a practical as well, how we can perform as a practical. I'll discuss it. Okay, no need to worry. Now apart from basics pre-processing, I also told you we have something called advanced pre-processing as well. Now let's try to see what are the steps are involved inside advanced pre-processing. So inside advanced pre-processing, we have something called parts of speech tagging. Parts of speech tagging. So if you're good with English grammar, I think you know what is parts of speech. Okay. Then you are also having something called parsing. Then you have something called co-reference. Okay, co-reference resolution. Now, if you want to understand them, let me show you one image. I think then this part would be clear. So guys, I think you can see this image. So here you can see this is the input text we are having. Chaplin wrote, directed and composed the music of for the most of his film. Now, if I perform tokenization and lemmatization, so I already told you what is tokenization. You will be taking individual words. See, here I have taken individual word here. And if you perform the lemmatization means it will bring the let's say any kinds of verb in a root word. Now you can see wrote. If I bring to the root word, it will be write. Directed, it would be direct. Okay. Then compose, it would be composed. It would be compose. So that's how actually you can understand the tokenization and lemmatization. Now, what is POS tagging? POS tagging means parts of speech tagging. The things I showed you in my advanced pre-processing. So this is what actually parts of speech tagging. That means you are assigning what is noun, what is verb, what is adjective. Okay. So that's how you are defining different kinds of parts of speech. If you're good with grammar, I think you will be understanding better than me. Just try to consider here you are tagging everything. That means you are tagging all the, let's say, noun, verb. Okay. Then pronoun, everything you are tagging. Now there is another one called parsing. Okay. I think I showed you parsing. So this is the parsing tree. That means you will be creating a tree. And inside this tree, you will have the entire sentence word. You can see Chaplin wrote, directed. Okay. All the words. So in the parts tree, you will be again assigning the POS tagging. Apart from that, you will be also dividing. These are the word in a separate form. Again, this is a advanced actually grammatical rules you have to learn, but no need to worry. Let's say whenever you will be working in the industry, there you will have something called domain expertise. Okay, let's say language expertise actually people you will get. So they will help you to do it, because I know as a developer, you don't know about, let's say, this English grammar and all. But whenever you will be designing the software, that time language expert will help you. Okay, how we can perform the parsing, how we can perform the POS tagging, everything they will help you out. Now, this is the last example, co-reference resolution. So co-reference resolution means, let's say, Chaplin wrote, directed and composed the music for the most of his film. Now here Chaplin and his, it is indicating the both person. It is indicating the same person, right? So this is called actually co-reference resolution. Sometimes your model has to understand this Chaplin and his. So it is mentioning the both. It is mentioning the same person. Okay. So this is called actually co-reference resolution, because nowadays if you see the ChatGPT, Gemini, so these kinds of application is able to understand. Okay, this kinds of input, this kinds of prompt. Okay. So in the backend actually they're handling like that. I hope it is clear now. Then the third actually step were available inside generative AI pipeline, which is nothing but feature engineering. Feature engineering. So inside feature engineering, you can perform text vectorization. So to perform the text vectorization, you can follow some technique like you have TF-IDF, you have something called bag of word, you have something called word2vec. You can also perform something called one-hot encoding. Then you can also use some transformers model to perform the text vectorization as well, because these are the very old technique. So if you're using any deep learning and machine learning model, that time you can use these are the technique. But if you are creating advanced application, like let's say if you're using large language model, transformer based architecture, like say encoder and decoder architecture, that time you have to use transformer model to perform the text vectorization technique. Okay, I hope it is clear. So these are the steps that are available inside feature engineering. So inside feature engineering, you will just try to convert your text to vector representation. It can be also work with the image as well. Let's say you are having an image. Okay, let's say you are having an image, and in that image actually you are having a cat image. Let's say this is a cat. Let's say this is a cat. Okay, now image is nothing but it's a pixel. So if you just see the image, so here you will see different pixel value. Okay, different pixel value. So that time what you can do, you can use any kinds of vision transformer model to convert this image to the vector representation. Okay, vector representation, and you can pass to the model. Okay, so that is the idea. Now fourth step, actually I think you saw, after feature engineering you can do the modeling. Okay, modeling means you'll be training the model. That means you'll feed the data to the model. Okay, so here you can choose different model. You can choose actually different kinds of model. So here you can either use open source, okay, open source LLM, that means large language model. Either you can use paid one. Okay, paid model. So what is the difference between open source and paid? See, if you're using paid one, this model would be available in the server. That means you don't need to download this model in your machine. Okay, so you don't need to download. Instead of that, what you will do, you will only, let's say, pass the data. Okay, let's say you are using OpenAI, because I think you know OpenAI provides actually paid model. That's a GPT model. So in OpenAI, you will upload your data, and in their server, it will train the model. Okay, you don't need to download the model in your machine, and you don't need to train there, because I know that people won't be having good GPU in their system. Okay, it's not possible actually to buy expensive GPU for training these kinds of large language model, because if you see this large language model, it's very huge. Okay, if you see the parameter size is very huge, so we can't download in our machine and we can train it. It's not possible. So that's why most of the time we'll be using cloud platform to train the model. Okay, so that time actually we can use the paid model, because paid model, if you're using paid platform, if you're using everything, they will take care. Only you have to upload your data there. But if you're using open source large language model, that time you have to download this model in your machine. You have to prepare everything. You have to set up the environment, and then you have to train the model. And for this, you need a good GPU. Okay, good GPU, good CPU, good memory. Okay, everything you need. And after training this model, you have to deploy this model in a cloud platform. Okay, manually you have to deploy this model in a cloud platform, and again you will get the challenges there. Like you have to buy a good instance, then you have to set up the load balancing and all. Okay, then you have to deploy this particular model. But if you're using cloud platform, they directly will get one option to deploy the model in their server only. Okay, so that people can access the model in their platform only. Okay, so you don't need to take care about the infrastructure. You don't need to take care about the instance. Everything they will take care. That is the difference. Got it? We'll be also understanding how we can use paid model, how we can use open source model. And I will also discuss the difficulty level actually you will be getting whenever you will be using open source LLM, whenever you will be using, let's say, paid LLM. Everything I'll try to clarify. No need to worry. Training your model, you have to perform something called model evaluation. Okay, evaluation. So inside evaluation, you have to perform two kinds of evaluation. One is like intrinsic evaluation, and that is like extrinsic evaluation. So intrinsic evaluation means you'll be using some metrics. Okay, you'll be using some metrics to evaluate the model. I think you know we are having different metrics for the evaluation. Let's say we are having accuracy score, R2 score, then we are having AOC card. So these are the different metrics we are having. Okay, so after training a model, you have to perform something called intrinsic evaluation, and this is performed by this evaluation will perform by the GenAI engineer. Okay, GenAI engineer, because they're training the model, and after training the model, they have to actually evaluate the model with the help of these are the matrices. And the extensive evaluation when they have to perform after doing the deployment. Okay, after doing the deployment. So this evaluation can be applied during the production. Okay, let's say whenever this model is in the production, people are using it. At that time, this extensive evaluation can be performed. Let's say I already told you, ChatGPT will launch one input. Sometimes it will ask you give the feedback. Not only ChatGPT, if you see any kinds of application. So if you just consider your phone keyboard, so whenever you use the keyboard, okay, so initially I think you won't be getting any kind of suggestion, but whenever you will be using that particular keyboard, okay, long time, then you will see that automatically you will get the suggestion, because it is learning. Okay, what kinds of input you are giving, it is learning, and sometimes it will ask for one kinds of feedback, whether you are enjoying this app or not. Okay, any feedback you want to give or not. And whenever you are giving the feedback, whenever you are giving the 5 rating, 4 rating, that time actually they are getting this application is working fine. There is no issue. But whenever you are giving negative feedback, that time they're getting actually there is some issue with the application. That time what they will do again, they will retrain the model. Okay, they will retrain the model, and they will again push the model through the production. Okay, so that's how extensive evaluation works. That means after deployment, after going to the production, okay, after going to the production of that model, you will be performing this particular extensive evaluation. This is the idea. And the sixth, I told you, we have to perform deployment. Okay, deployment. And inside deployment, you will be also doing the monitoring and retraining. Okay, retraining, because you will be doing the monitoring in the extensive evaluation, and if something going wrong, you'll be doing the retraining of the model. This is the idea. So these things are involved inside so the entire generative AI pipeline. I hope it is clear. So first of all, data acquisition, then data preparation, then feature engineering, modeling, evaluation, and deployment. And here one thing you have to remember, because going forward I'll be using this term a lot. So let me just write here a common term. Let me copy this text and let me paste here. Let's say this is my data. Now here you will see some of the actually, let's say, common term. The first term actually we'll see called corpus. Okay, corpus. Then the second term you will see, which is nothing but vocabulary. And the third term you will see, which is nothing but documents. And the fourth you will see something called word. Okay, word. Now what is corpus? Corpus is nothing but the entire text. Entire text. That means the entire text is called corpus. Okay. And what is vocabulary? Unique word. Unique word. Now you can see this is unique word, this is unique word, this is unique word, this is unique word, this is unique word. Okay. So these are the word is unique. And if you see any of the word is coming duplicates, only you have to take the unique word. Okay. This is called actually vocabulary. Okay. Then what is documents? Document is nothing but one row. That means one line only. So till here actually one documents, D1. Then this is called actually D2. Okay, D2. Then D3. So this is called actually documents. So I can write one line. Okay, one line is the documents. Okay, or one row. And what is word? Word is like thus single word. Okay, single word is called word. So you can see this is a single word, this is a single word, this is called actually word. So these are the common term you have to remember, because going forward, whenever we'll be actually playing with the data, that time actually I may tell you these are the actually common term. Okay, that time you won't be getting confused. What is corpus? What is vocabulary? What is documents? What is word? Okay, that's fine. So that's why I showed you. Okay, here in this video. So yes, guys, these are the actually generative AI pipeline, and here I have just showed you as a theoretical. So in the next video, we'll be doing the practical of it, like how we can perform different text cleaning technique, like different text preprocessing technique. After that, we'll also see how we can perform feature engineering technique as well. Okay, different feature engineering technique. Because what I feel like, before starting with our large language model, first of all, we have to understand the data. First of all, we have to know how to prepare the data for the model. Okay, then we'll be starting with the large language model. Okay, so this thing actually is So this thing actually very important before learning your generative AI, before learning the large language model and application building. So that's why I'm teaching you this part. In our previous video, I already discussed about end-to-end generative AI pipeline. So there I told you what is the use of data pre-processing, right? Because if you want to use the model, that means large language model, the first thing you have to do the data pre-processing, because unless and until you are not processing the data, how your model will try to understand that one, right? That is the idea. So here we'll be learning various kinds of technique to clean up our data. So for this, what I have done, I have created a beautiful Colab notebook. So there actually I have added all the examples you can use for the data cleanup operation. So guys, now let's try to see how we can do the data pre-processing part. So guys, as you can see, this is the notebook I already prepared. So here you can see I'm using one dataset from Kaggle. So let me open the link. This is the link. So the dataset name is IMDb dataset, and it is having actually 50k movie reviews. Okay, 50k actually movie reviews. If you are already from, let's say, machine learning, deep learning background, I think you know about this dataset, right? It's like very common dataset. And why I took this particular dataset, because in this dataset you will see there are so many actually unnecessary text. Okay, because it's a movie review. So what they did actually, they extracted, they scrapped this data from the IMDb website. If you don't know, this is the IMDb website, IMDb. So in this website you will see all the movies reviews and rating. And what they did actually, they published this dataset in the Kaggle website, so that if anyone is working in the field of, let's say, generative AI or natural language processing, they can use the dataset. Now here, what you just need to do, you just need to download this data. Okay, it's around I think 27 MB. Just click on download button, it will download. Okay, so I already downloaded this dataset, so it is available inside my download folder. So I'm going to upload in my Colab notebook. So here, first of all, what you have to do, you have to connect this particular notebook. So there is a connect button, just try to connect. And no need to worry, I will also share this notebook link in the resources section. From there, you can open it up. So my notebook is connected. So first of all, let's import some of the library. First of all, I need something called pandas, because if you see the data, it's a CSV data. Okay, it's a CSV data. So let me upload and let me show you. So if you want to upload anything in the Google Drive, just try to right click and there is an upload button. Click on upload and try to upload this data here. Now see, it's a CSV file. Okay, and if I want to load any kinds of CSV file, JSON file, or let's say Excel file, whatever file, you can use the pandas package for that. So you can see my dataset is uploaded. Now, if I want to load the dataset, what I have to do, I have to assign the path. And see, you don't need to execute this at the code, because this code I have added. Let's say if your dataset is available in your Google Drive, that time what you have to do, you have to mount your Google Drive first of all. Mount means you will be connecting with your Google Drive. Then we'll be relocating the folder. Okay, like inside which folder you kept your data. Okay, with the cd command. CD means change directory. Okay, then after that, what you will do, you will assign the data path. But here I haven't kept my data inside my Google Drive. I kept inside my Colab. Actually, you can see drive. This is the Colab disk I'm using. Here you will get around 74 GB of space. So here you also can keep your data. So I don't need to execute this code. What I will do, I'll just go below. And if I check my current working directory, that means pwd, you will see I'm inside content. Content means this is the directory right now. Now here, I'll just simply define my data path. So I'll copy the path, copy, and let me paste it here. Okay, that's it. Now let me execute. Now see, if I now load the data, pd.read CSV I'm doing. So now see, it will load the data. See, it has loaded the data. If you want to see the shape of the data, this is the shape. Okay, you have around 50k actually movies reviews in this particular CSV file, and two columns. Two columns means one is the reviews column, another is like the sentiment column. Okay, sentiment means whether it's a positive sentiment, whether it's a negative sentiment. This kinds of sentiment you will get here. I hope it is clear. Now see, here I'm having 50k movie reviews, but here I'm not going to use all the reviews. Here I'm going to show you the demo, like how we can perform the text pre-processing. And if I'm taking all the 50k reviews, so it will take like lots of time to process those at the text. So what I will do, I'll only take the 100 example. Okay, the first 100 example I'll be taking, and on top of that, I will perform all the text processing task, right? So this is the code you can execute. So it will load 100 example. Now if I show you the shape, see, now we are having 100 example and only 2 columns. Fine. Now if I want to show you the data, see, this is the data. So I think you remember in my theoretical class, I was discussing about some pre-processing technique here, I think. So here you can perform something called HTML tag removal, emoji handler, then spelling correction. Then in the basic preprocessing, we saw that we can perform something called tokenization. Then we had some optional preprocessing as well, like stop word, streaming, lemmatization, punctuation, lowercase, okay, language detection, each and everything. So first thing we'll be learning how we can perform the lowercase operation. And why lowercase is important, I already explained here. I think you remember. Let's say if one of the name is containing uppercase character, it will consider these are actually separate name. Okay, these are actually separate entity. That is the idea. So that's how we have to bring everything in a lowercase character. So that's how you have to apply this lower operation. And how to perform lower operation, I think you already know. In Python, we are having a function called lower. With the help of lower also we can do it, right? Now see here, let me show you one example. Let's say I'm taking the reviews 3. So here I'm taking the three number rows. This is the 3 number rows. Now you can see some of the character is uppercase character here. So this is uppercase, this is uppercase. Okay, so that's how actually you will see different uppercase character would be there. Now if I want to make them lowercase, what I have to do, first of all I have to select my column, like in which column you have to apply the lower function. I have to apply on top of my review column. Now first of all I'm converting everything to the string, okay, string data type. Then I'm applying the lower, because lower is a string method. Okay, lower is a string method. I think you already know that. Then whatever changes actually I'm doing, I'm saving inside my column. That means I'm just doing the permanent change, okay, inside my column. So that's why I've given a review again. That is the idea. Now if I execute, now see if I show you the data. Now see guys, all the character has become lowercase right now. Now if I want to show you the, now if I again execute that review 3, you will see that all the character has converted to the lowercase character. Okay, that is the idea. Now the next thing we'll be learning how we can handle the HTML tags. That means how we can remove the HTML tags. For this, here I have written a function. Here I'm using something called regular expression, regex. Okay, so inside regex you can give a pattern. That's, let's say here you are giving a pattern. If you are getting this kinds of symbol, okay, if you are getting this kinds of symbol, it's a like HTML tag. You have to remove those HTML tags and you have to replace with empty. Okay, empty string. That is the idea. Now this is the function we can use. Now if I execute, now let's say this is a one text I have prepared. You can see in this text actually we are having lots of HTML tags. Now if I pass this particular text to my function, see it will automatically remove all the tags. Now see, I'm only getting that text, okay, relevant text. That is the idea. So this notebook I prepared in such a way so that you can use it as a template. Let's say whenever you need anything, any kinds of functionality, you can come here, you can copy those functions. So please try to keep this particular notebook with you, because this is going to help you a lot. Okay, whenever you'll be developing the projects, this is going to help you a lot. Now if you want to apply on top of the entire data set, again just call this column name, let's say review column, okay, and there is a function called apply, and inside that just try to pass this function. Okay, apply function takes actually one function object. Now here I'm giving the function object. So what it will do, it will try to apply this particular function on top of the entire rows you are having in your data set. Okay, now see if I execute, and the changes actually I'm doing, I'm saving everything permanent. Okay, now let me execute. Now if I show you any kinds of random, let's say rows, now you'll see all the now let's see if I also show you 7, okay, 7 number rows. Now just try to see, there is no HTML tags in this particular text. You can pick up any kinds of, let's say index. So let's say if I show you the 10, nowhere you will see the HTML tags here. Now we'll be learning how we can remove actually URL. Let's say if you are having some URL in the text, how we can remove it. For this again I'm using regular expression, and there is a pattern I have given. If you are getting this kinds of, let's say a word HTTP then slash then www, that means it is a URL and you have to remove the URL with the empty string. Okay, this is the function. Now let me execute. Now here I have just mentioned some of the URL. So this is my YouTube channel URL, this is my LinkedIn URL, and google.com and kaggle.com. Okay, now these are the text I have prepared one by one. Now let's say if I'm passing any kinds of text inside my remove URL function, it will remove that URL. Let me show you. See, I'm giving the text to, that means my LinkedIn URL. Now you can see, check out my LinkedIn. I hope it is clear. See, again I'm telling you, it's not a mandatory things. Let's say you need URL in your data. At that time you can keep it. Let's say you need actually HTML tags, you can keep it. But if you don't need it, you can remove it. Because I already told you, nowadays actually we are having advanced generative AI application. It also supports all kinds of text like emojis, HTML, okay, everything it supports. So if you are creating this kinds of advanced, let's say, application, that time you need these are the data. You don't need to remove it. Okay, but sometimes actually you also need to remove this data set. So that's why I'm showing you how we can remove it. And if you want to keep it, you can also keep it. It's up to you. Okay, you have to decide based on your project architecture at that time. This is the idea. Now we'll be learning how we can handle the punctuation. So if you want to see the punctuation, so there is a string package you can use. Now if you just write string.punctuation, you will see all kinds of punctuations are available. Now what I have done, I just stored these are the punctuation in a variable called exclude. Now here I have written a function. Okay, here I have written a function called remove punctuation, and here I have written a for loop. So I'm just looping through this punctuation one by one, and user is giving the text, and I'm just checking whether if there is any punctuation. Okay, I'm just replacing with the empty string. Now let me show you how it will work. Now let's say this is one text string with a punctuation. You can see there are so many punctuation I have assigned. Now if I pass this particular text to my punctuation functions, it will remove the punctuation. Now see, there is no punctuation right now. Even I'm also calculating the time, like how much time it is taking to remove the punctuation, because there is another way you can follow to remove the punctuation. I'll tell you how you can do it. See, this is the function, guys. So here you can use something called text.translate. Inside that, just try to use this particular function. Okay, make translate, and inside that just try to mention the punctuation. So what it will do, it will take your text and it will remove all the punctuation. So this is another approach. Now see, if I calculate the time of this function, you will see that this is the time. That means this function is taking less time than your this function, because here you are using one for loop, and for loop has the linear time complexity. I think you know that. If you are familiar with DSA concept, I think you know that it is having linear time complexity. Okay, so this particular approach is good. So let's say if you are applying this particular logic on top of 50k data set, just try to think how much time it will take this for loop. And in other hand, if you are using this particular method, it will take very less time to perform the operation. Now if you want to see the time difference, you can also see the time difference. Now if I show you my text, now see, inside this text actually I'm having lots of punctuation. Now what I will do, I will use my remove function one, that means this particular function, and inside that I'm going to pass my entire review. Now see, it will remove the punctuation. Okay, see, all the punctuation has been removed. Now you can also pass the entire data like that. You can also pass the entire data. It will remove all the punctuation inside your entire data. Now we'll be learning how we can handle the chat conversation. See, sometimes whenever we perform the chatting operation, we give like lots of shortcut. Let's say if I want to write as far as I know, what you will give? You will give AFAIK. Then let's say away from keyboard, AFK. Then as soon as possible, ASAP. That's how we use lots of chat keyword. Okay, we use lots of chat shortcut keyword. Okay, here I have listed down some of them. You can see for your information, FYI. So that's how I have listed all the chat conversation short word. Now let's say you are working with actually social media dataset. In the social media dataset, you will see these kinds of data a lot. People will be using short form. Okay, short form. So how we can handle this particular short form? For this, first of all, try to create a dictionary like that. The entire dictionary you have to create. Then after that, here I've written a function. So this is the function chat conversation handle. So inside that, I'm just taking the text. Okay, I'm just taking the text and I'm checking. And inside that, with the help of this for loop, I'm checking if we are having these kinds of word. Okay, if you are having these kinds of word, what we're doing, we're just mapping with the value. That means, let's say, if anyone having actually this particular, let's say, a shortcut word, let's say FYI. What I will do instead of FYI, I will just return for your information, because this is a dictionary. If I want to get the value, I want to call the key. Okay, that's how we are mapping. Now see, if I execute the program. Now let's say here we are giving a short message, do this work ASAP. Now see, it will return me, do this work as soon as possible. Okay, because here it is coming here and it is mapping and it is giving me this value. Okay, this is the idea. Now let me see how we can handle the incorrect text. Let's say sometimes what happens whenever you are using real-time data, there would be lots of spelling mistake, right? Let's say this is one example, certain spelling is not correct, then condition spelling is not correct. That's how you'll see different word is having the spelling mistake. So how to handle this spelling mistake? For this, you have to use one package called text blob. So let me import this text blob. And now see, here I'm having my incorrect text. Now if I pass this incorrect text to my text blob, and if I call this particular function called correct, now see, it will handle everything. Now see, certain conditions during several, see, all the word has been corrected. So this is one amazing package you can use if you want to handle the spelling. Okay, spelling of any word. Now the next thing we'll be learning how we can handle the stop words. So inside English language, not only English language, inside all kinds of language, we're having some stop words. Okay, now here we're working with the English language. So let me show you some English related stop words. For this, I will be importing stop words from the NLTK. NLTK is nothing but it's a natural language toolkit library. So with the help of NLP also, you can perform lots of NLP related tasks. So here you can see I'm importing the stop word. So here I'm performing NLTK.download. It will download all the stop words from the internet. Now see if I click this cell, it will download the stop words. Now, if you want to list down all the stop words, you can just write stop words dot words, and here you can specify the language. So here I'm working with the English language. So here I've given the English. Let's say you are working with Hindi, Bengali, you can give that language also. It will give you the stop word related that language. So you can see the documentation of NLTK. We'll see that how we can pass the parameter here. Now see, these are the words we are having inside English. So this is called stop word. So this word doesn't have any kinds of meaning, okay, in a sentence. Okay, we use it to represent one sentence, but there is no meaning. So let me show you why I'm telling there is no meaning. Let's see if you want to perform sentiment analysis. So let's say there is one review we are having. So let me just write, this movie is awesome. I loved it. Now just try to see, here you are having some stop word, right? Like is there, this is there, I is there, it is there, right? But if I want to get the sentiment of this particular, let's say reviews, I can see movies is required, awesome is required, loved is required. Now if I'm getting these kinds of word, actually, this kinds of positive word, that means it's a positive sentiment. Okay, it's a positive sentiment, yes or no, right? So here actually I don't need these are the stop word. Okay, I don't need this as the stop word to understand whether this particular reviews is a positive or negative. And if you're using these are the stop word in the sentence, so what will happen whenever you will perform the text vectorization, it will make actually extra dimension. Okay, it will make the extra dimension in the data. And whenever it is making the extra dimension, that means if dimension is increasing, that time your model might get difficulties, right? Because we know that there is a concept of curves of dimensionality. So we always need to reduce the dimensionality somehow. I think you have learned in your machine learning. Okay, machine learning, let's say, topic. So that is why we don't need these are the stop words. So we have to remove this particular stop word sometimes. And sometimes actually we have to also keep it. So these are the stop word, guys, you saw. Now let me show you the length. So around we are having 179 stop words present inside English. Now here I've written a function. So this function will remove the stop words from a text. Now let me show you. Let's say this is a text I have given. So inside that you can see different stop words are there. Now if I pass to my function, so see, now see, there is no stop word in this particular text right now. Okay, that's how you can use this particular function. Now again, this is my data. And if I want to apply on top of my entire reviews, I can do it. I can use the apply function and I can pass my function object, remove stop words. And if you want to store permanently, what you can do, you can write this code. Okay, df reviews is equal to df reviews apply stop words. Okay, it will save everything permanent, but I don't want to save it permanent as of now because I'm showing you as a demo. If you want to do the permanent, you can do it. So now guys, I think it is clear how we can remove the stop words. Now the next thing we'll be learning how to handle the emoji. Okay, see, emoji is nothing but it's a Unicode actually character. Okay, if I show you, if you just write emoji Unicode, you will see different Unicodes of different emojis. So let me open it up. See, here we are having different emojis. Based on that, we are having the Unicode. Okay, Unicode character. Okay, Unicode character. So that's why I just collected some of the Unicode character, like for the emotions emojis, symbols, then pictographs. Then we're having transport, map, symbol, flag. Okay, so these are the emojis related Unicode I collected here, and I just written a function. Okay. And again, I'm using the regular expression. So here I'm telling if you are getting this kinds of Unicode in a sentence, that means it's an emoji. So what you have to do, you have to remove those emoji with an empty space. Okay, now let me show you. So let's say this is one text I'm giving. Love the movie, it was flying kiss. Okay, now see if I pass this particular text, now see it will remove the emojis automatically. Now this is the next one. Now see, only Lamo is coming. Now sometimes actually I told you emojis are required. Because let's say I told you in the ChatGPT example. So if you pass any kinds of emoji to the ChatGPT, it will also able to understand, okay, what you are trying to say. Let's say if I pass any kinds of emoji here, let's say I'll give this emoji. Hey there, what's on your mind today? See, it is trying to understand my feelings, right? Now, if I want to handle these kinds of situations, what I have to do, I have to keep the emoji. That time, what I can do, I can extract the meaning of the emoji. So for this, I can use one library called emoji. Okay, now let me show you. First of all, you have to install it. Now just import the emoji, and inside emoji you are having one method called demojize. Okay, now inside that just try to pass the text. Python is fire. I'm giving the fire emoji. Now so it will automatically convert to the word Python is fire. Okay, that means it is trying to extract the meaning of that particular emoji right now. I hope you cleared. So that's how whenever you are passing any kinds of emoji as an input to the chat GPT, it is trying to convert this emoji to the word and is trying to understand what you are trying to say. Now there is another example I have given. I love this movie. It was flying kiss. See, love this movie. It was face blowing a kiss. Now we'll be understanding the tokenization. I told you we are having two kinds of tokenization, sentence level tokenization and word level tokenization. So let's try to see. See, if you want to perform the tokenization, directly you can use the split function, because the split also will give you the individual word in a list. See, if I have one sentence, now if I perform the split operation, see, I'm getting actually individual word. So with the help of split also you can perform the tokenization. So similar wise, you can also do the sentence level tokenization. This is the word level tokenization. Now for this, you have to mention this particular full stop sign. So whenever it is getting the full stop, that means this is one sentence. Okay. Now see, if I execute, so here I'm having 3 sentences. So I am going to Delhi. I will stay there for 3 days. Let's hope the trip to be great. Okay. See, 3 sentences I'm getting. So this is called sentence level tokenization. So again, some of the example with the split function. Now with the help of regular expression, you can also do the tokenizations. So this is one example I kept with the regular expression. So here is my sentence and it will give you the individual word. This is the sentence level tokenization. Okay. And this is the pattern for the word level. This is the pattern for the sentence level. Okay. This is the idea. Now you can also use something called NLTK. Okay. That means Natural Language Toolkit Library for the tokenization as well. Inside that, we are having two actually function, word level tokenizer and sentence level tokenizer. Now let me, and if you want to perform the tokenization, you have to download this particular thing called PUNKT. Okay, this particular thing you have to download. Okay, now see, here is my sentence and I want to perform word level tokenization. I will pass this, so it will give me the word level tokenization. So automatically this function will handle. Now if you want to perform sentence level tokenization, you can use sent tokenizer. Okay, from here, and you are getting the sentence level tokenization. Okay. So again, some of the example you can try, I have given, and I created this notebook in a such a way you can use it as a template. I already told you I have written like the function wise, right? If you need any kinds of, let's say, cleanup technique, you can copy from here and you can use it in your code. That's the idea. Now there is another package you can use called Spacey. With the help of Spacey also you can perform the tokenization. Fine. So you can explore this part. Now let me go to the schema. Okay. I already told you what is schema. Schema means you are trying to bring the different word in a root form. That means let's say you are having play, playing, played. So what you will do, you will apply schema and you will just try to convert it is to the, and you'll just try to convert to the root word, that means play, right? Because it is meaning the same, okay, in a sentence. So now let me show you. So inside NLTK we are having this streamer, porter streamer. Now we are importing porter streamer, and here we have created the function steam word. So whenever you will give any kinds of, let's say, sentence, it will perform the streaming operation. Now see, here I'm giving walk, works, walking, work. Now if I give this particular sentence, it will give me the root form. That means walk, 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 and all. Okay. Now see, here I kept one sentence. So this is the entire sentence you can see. Now I want to perform streaming operation on top of the sentence. So I'm using my function. Inside that I'm passing the sentence. Now see, it will give me the streaming word right now. Now see, probably it has been probable. Okay, probable. That's why I told you streaming is not readable. Sometimes you will get some kinds of word, it's not readable, but your model will try to understand. Okay, but as a human, it's not readable. See, favorite has been converted to favorite right now. Okay, so in case actually what you can do, you can use something called lemmatization. Okay, lemmatization will handle this kinds of situation. It will give you a readable word actually. Now see, this is the lemmatization code. So it is available inside NLTK. I'm importing the lemmatization, initializing the lemmatization, and if you want to use lemmatization, you have to download these at the things, WordNet and OMW. And now if I execute this code, you will see that it will give you the lemmatization for all the words. See, so this is the word, this is the lemmatization, this is the word, this is the lemmatization. Now see, it's readable. Okay, it's readable than your streaming one. I hope it is clear. Fine. So that's why I just written streaming and lemmatization are same to retrieve root words, but lemmatization is worked good, lemmatization is slow, and streaming is fast, because lemmatization will give you the readable output. That's why it's a little bit slow than your streaming. Okay, I hope it is clear. So yes, these are the technique you can follow for the text pre-processing. If you are having any kinds of text, you can perform text pre-processing with the help of these are the technique. You can clean up your text. Okay, and again I'm telling you, it's not required to perform all the text cleaning technique. Sometimes if you need anything, just try to keep it as it is. That is the idea. Fine. So yes, this is all from this video. And what you can do right now, you can download any other dataset from the Kaggle.com, because Kaggle is having different dataset, not only movie dataset. You will also get something called Twitter dataset. I think Twitter dataset is also available. See, Twitter dataset is also available. Just try to download the Twitter sentiment dataset and try to apply. These are the text preprocessing on top of the Twitter dataset. Okay, so this should be one task, guys, from my side. Please try to attempt, because unless and until you are not practicing, things would be more complicated. And whenever you will be doing the practical, okay, by yourself, things would be more clear here. So in the next video, we'll be learning how we can perform the data representation, that means text representation, how we can vectorize our text, that means we'll be converting our text to numbers, okay, for the model. So I think you already know what is data representation. That means inside generative AI, you will be working with textual data. So not only textual data, you will be also working with something called image kinds of data. Now, these are the actually raw file. If you see any kinds of text data, any kinds of image data, okay, so these are actually raw data. These are actually unstructured data. So I can't directly pass these kinds of data to my model, because model is nothing but at the end, it's a mathematical equation only, right? And mathematical equation can only support numerical data. So what we have to do, whatever text data, whatever image data we are using here, we have to convert them to the vector. That means we have to convert them to the number, okay, numerical representation. So this concept, we call it as a data representation. You can also call it as a data vectorization, okay? So here we'll be seeing couple of technique we can follow to perform these kinds of vectorization technique on top of our data. Even I will also show you some drawbacks with different technique, and which technique actually at the end you have to follow for the generative AI. If you're working in the generative AI, if you're working with the large language model, so which technique would be suitable for your task, okay? So here everything I'll try to clarify. So please try to watch this video till the end. And if you have any kinds of doubt, you can also ask me in the comment section. So let's start, guys, with our data representation topic. So guys, in this video, I'll be discussing about like what is feature extraction from text. You can also consider as image. Then we'll be discussing about why we need it. Then third, I'm going to discuss why it is so difficult. Then we'll be discussing about what is the core idea and some techniques. So this should be my entire video agenda. So first of all, we'll be discussing about what is feature extraction from text. You can also consider as image, because I told you na, in generative AI, you can use any kinds of data, whether it can be text, image, audio, okay, anything. See, first of all, we have to understand what is feature extraction. See, feature extraction is nothing but, let's say you are having a unstructured data. Let's say you are having a text data, or let's say image data. So from this data, you are extracting some features to represent that particular data. So I think those who are already familiar with computer vision, you already learned about convolutional neural network. So with the help of CNN, what we can perform a feature extraction. That means we just try to extract some of the features from an image. So what kinds of features? Let's say the edges, okay. Then you'll be also extracting some patterns. So these are the actually features. So with the help of these particular features, my model will be able to understand about the data, and it will be able to predict something, okay, on top of the test data. So this is the idea. So in generative AI also, what kinds of data actually we're using, we also need to perform something called feature extraction, because whether it can be text data, image data, any kinds of data, the first thing what you have to do, you have to extract the features from that particular data. Okay, this is the idea. And feature extraction means you are converting your textual data to numerical representation. That means to the vector representation. Okay, this is the idea. Then the second thing actually you can see why we need it. Because as I already told you, in generative AI, whatever model you are using, whatever large language model you are using, every model is a mathematical equation. And mathematical equation can't take actually your textual data or image data directly. So for this, definitely you have to convert to the number. Okay, numbers. You can also call it as a vector. Okay, vectors. So if you can convert to the numbers or vectors, then your model will be able to take this particular data as an input, and it will learn, okay, what kinds of actually pattern it is having. Based on that, it will try to generate something. This is the idea. Okay. Now, why it is so difficult? So whenever I'm talking about text data, okay, whenever I'm talking about text data, it would be a little bit difficult for you to extract the features from the data. Why? So let me show you some example. Let's say if I'm considering, let's say ML in machine learning, I think you remember inside machine learning, what kinds of data we used to use? I think you remember we used to use something called tabular data. Okay, tabular data. Tabular data, like we used to use something called CSV data, then Excel. Fine. So these are actually tabular data. That means here you will have a table. So let's say this is your table. So it will have one fixed table. So in this table, you will have the fixed column size. Let's say you are having here 1, 2, 3, 4 column and sum of the rows. So 1, 2, 3, 4 columns. 1, 2, 3, 4, 5 rows. Okay. So here your table dimension is 5 cross 4. Okay. So this is the table dimension. That means it's a fixed size. It's a tabular data. Okay. It's a tabular data. So here you will have the column. Okay. Here you have the column. And here you will have the row. I hope you cleared. Now you will store the data. Fine. Now, whenever you are taking any kinds of, let's say, machine learning model, let's say this is your machine learning model, your ML model. So what you will do? So so what is the X feature size? X feature size is nothing but your input size. Okay, input size, that means the independence variable. Let's say you are doing house price prediction. So let's say this is number of room. Let's say this is the area of the house. Let's say this is number of bathroom. And this is the price of the house. So this is your Y variable. Okay. And these are your X variable. Okay. So X variable, I'm having how many? 1, 2, 3. 3 X variable I'm having. Okay. That means you will give 3 input to the model and only 1 output you will get, which is nothing but Y hat. Okay. This is the idea. That means to the model, you have to give X data, 3 column, and Y data, 1 column, which is nothing but your price. And this is your target variable. Okay. And once you pass the data, you will get the output. That means here your column size is fixed. So here what you saw, your column size is fixed. That means your input size is fixed. Okay, to the model. Okay, there is no issue. That means we can easily use our tabular data. Okay, for in the machine learning, or you can also use in the deep learning. For this, you have to use something called neural network. That means artificial neural network, right? Now let's consider image data. Let's say inside computer vision, we use something called image data. Okay, image, videos. And whenever I'm talking about videos is nothing but it's a frame of image, right? It's a sequence of image. So you can convert videos to image, then you can analyze, again you can convert to videos. So let's consider image only here. So let me show you. See, image is nothing but it's a pixel. Okay, inside image actually we'll see different pixel values. So let me show you one example. So guys, here you can see here I kept one image, and this is a MNIST digit image. So here you can see 3 has been written. So if you just zoom this image, what you will see these kinds of pixel. Okay, and inside pixel you are having different numbers. You can see these are actually numbers. So this number range would be 0 to 255. Okay, 0 to 255, this is the range of the number. And one thing, wherever you can see the 0, okay, 0 number, you can see it's a white pixel. Okay, it's a white pixel. And whenever you see some number, okay, it's a black pixel. You can see whenever you can see much darker color, it's a that means it is close to 255. And whenever you see some mild like darker color, that means it is close to 0. Okay, so this is the idea. Let's see your 3 looks like that. Let's say this is the 3 in this image, and here is the 3 representation in the number. That means if you zoom this image, you will see some numbers, that some value, pixel value would be there. Okay, so that's how actually your 3 looks like. So whatever image you are taking, you'll be getting this kinds of pixel value. Okay, at the end. Now whenever I'm talking about image data, so you can easily convert image to a table representation because it's a pixel value at the end. So what you can do, you can create a fixed table. You can create a fixed table. Let's say this image dimension is 28 cross 28. Okay, now just try to calculate the pixel value. Based on that, just try to create the table and add all the number here, add all the pixel. Now if you calculate all the pixels here, so if you just multiply 28 cross 28, you will get something called 784. Okay, I think that many of pixel. So this should be your input size. Okay, this should be your input size. Now what you can do, you can create a neural network. Okay, ... 784. Now just pass all the data one by one. Okay, pass all the data one by one, and so on. Okay, till 7 84. Okay, so that's how again you can create a easy neural network. And here input size is also fixed, which is nothing but this is the input size, because all the image will have the dimension, fixed dimension. Okay, I hope it is clear. That means there is no issue with the input size. Now the next data, let's talk about audio data. Okay, audio data. So audio is what? Audio is nothing but, so what is audio? Audio is nothing but it's a frequency. You can see it's a frequency. So whenever you will see some audio, you will get this kinds of frequency response, and the parameter of the audio would be dB. Okay, that means decibel. Okay, this is the frequency of the audio. Now you can easily convert this audio signal to a number representation, because here you can see, let's say this is your hertz. Okay, this is your hertz, frequency hertz, and this is your dB, that means decibel. Like, and now you can see this is the actually frequency. Now just try to see the graph, and based on that just try to collect the number. Let's say you have created one table. Let's say this is your table. So one column you just consider, let's say this is the frequency and this is the decibel. Okay, dB. Now just try to collect the data. Let's say here you can see 400 hertz and the decibel value was, let's say, minus 10 dB. Okay, that's how just collect all the data. Okay, collect all the data. Now again you will see we'll have one fixed table. Okay, we'll have one fixed table. Again you can take a deep learning model here, let's say artificial neural network, and you can feed the data. You can feed the data and you can get the prediction. Okay, again you don't have any issue with the input size. But whenever I'm talking about, let's say, text data, whenever I'm talking about text data, so here you will get the difficulty. How? So let me show you. So let's say this one sentence I'm having, my name is Bappy. So here just try to see how many tokens you are having. So we are having 1, 2, 3, 4. That means 4 tokens. Let's say somehow you converted this text to a number representation, that means vector representation. Let's say my you are considering as 0, name you are considering as 1, is considering as 2, and Bappy you are considering as 3. Now you will be creating a network. Let's say this is your neural network, 1, 2, 3 and 4. Then what you will do, you will feed the data. Let's say my will come here, name will come here, is will come here, and Bappy will come here. Okay, now let's say you have taken some hidden neural network, and here you will get the y hat. Okay, now let's say there is another sentence, how are you? Now see, here you will get the difficulties, because in the previous sentence how many tokens I had 4 tokens. Now if you count this sentence, you are having 1, 2, 3, only 3 tokens. Now let's say you have represented these tokens 4, 5, 6. Okay, let's say this is your vector representation. Now tell me, can I pass this particular data to the model right now? Because what is the model input size? 4. But here what is the input? You are having 3. So here you will get one dimensional issue. Okay, dimension issue you will get. Okay, so it will give you one error. So it is expecting 4-dimensional input, but you have given 3-dimensional input. Now just try to consider, whenever we write any kinds of text, it doesn't have any kinds of input length similarity. Okay, you can write anything. You can write, my name is Bappy, how are you? I'm okay. So it should be any kinds of length sentence. Okay, it can be any kinds of length sentence. And there actually we usually face the difficulty whenever we use these kinds of textual data, because it doesn't have any kinds of input size, because it's a completely unstructured data. And representing this text to numbers is very much difficult, because I can't assign 0, 1, 2, 3 like that. Because if you're assigning 0, 1, 2, 3 like that, your model won't be able to understand. It's not a meaningful number. But previously, the data I showed you, we can easily convert them to the numerical representation, because tabular data is already a numerical representation data, right? Then image is already a numbers, because at the end you are getting a pixel here. Then audio is already a number, you are getting a number here. But what about text? Text is a string. But how we can convert a string to a number representation so that it will have the same meaning of my sentence. Let's say here I have written, my name is Bappy. So after my name is coming, after name is coming, after is Bappy is coming. So with the help of number, how I can, let's say, contain that particular relationship? Is it possible? Yeah, it is possible, but it would be a little bit difficult for you initially, because you don't know like what kinds of, let's say, vectorization you can perform here to represent this particular sentence to a, let's say, meaningful representation. That is what I'm trying to say, right? So now you can ask me, sir, we can apply actually 2 techniques we have learned previously. I will tell you what kinds of technique we can apply. You told me, let's say the first technique we can apply something called one-hot encoding. One-hot encoding. So this encoding technique you have learned in your machine learning, right? That's whenever you have any kinds of categorical data used to perform this one-hot encoding, right? Then the second technique you can also perform something called bag of word. Bag of word. We can also call it as a bow. Okay, bag of word. So now let's try to discuss these two technique, how it can be applied and what are some drawbacks. Okay, if I were applying these kinds of technique. Okay, so first of all, let me discuss one-hot encoding. So what I'll do, I'll just create a table here. So let me create a table. So here I will take 2 columns and 4 rows. As of now, I'm only taking 4 example just to show you, okay, how things will be working. But in actual way, we'll have more than actually 4 rows. Okay, that means you might have thousands rows, let's say lakhs of rows. Okay, it doesn't matter. Let's say this is your data 1. So here you are having a sentence. Let's say people watch. Let's say I'll give my YouTube channel name DS with Bappy. So if you don't know, guys, this is my YouTube channel name. If you're interested, you can also visit. Then let's say data 2 we are having DS with Bappy much DS with Bappy. I'm writing any kinds of sentence, guys, as of now. Whatever things I'm thinking in my mind. Now it's a data 3 you are having people write comments. And data 4 I'll be writing D4 DS with Bappy write comments. Okay, let's say these kinds of data we are having initially. Fine. So that means how many rows we are having? We are having row 1, row 2, then row 3 and row 4. That means only 4 row we are having as of now. Okay, for example, we are having 4 data points we are having, right? Now, if I want to perform one-hot encoding, so first thing what I have to do, I have to take the entire corpus. Okay, and I already told you what is corpus. I think in my previous session, the text preprocessing session, at the last I was discussing about some like key important things you have to remember. Okay, so whenever I'm talking about corpus, that means your entire data. So just try to collect your entire data. Let's say people, then you have the watch, then you have the DS with Bappy, then you are having then again you are having DS with Bappy, DS with Bappy, then again watch, then again DS with Bappy, then you are having people, then write, then comments, then again DS with Bappy, write, comments. Okay, so this is your entire corpus. Okay, corpus. Okay, corpus of your data. Now from here you have to figure out how many unique word you are having. So we are having people, we are having watch, DS with Bappy, then write and comments. So these are the unique words. That means 1, 2, 3, 4 and 5. That means n is equal to 5. Okay, 5 unique word we are having. Now what we have to do, we have to create a table. Let's say I'll create a table with these 5 unique words. So the first word will come people. The second one will come watch. Then the third one will come, let's say DS with Bappy. Then write. Then comments. Okay, comments. Okay, so that's how your one-hot encoding will try to represent the data. Okay, let's say whenever you are using any let's say library in Python, so how this library works exactly to perform the one-hot encoding, that is what I'm explaining here. Fine. Now see how it will try to convert your text data to numerical representation. So first of all, it will take the row 1, that means D1, let's say people. Now just try to find people here. So you can see people is there, that means this should be 1 and everything would be 0. Okay, then watch. Now just try to find out the watch. So here is the watch, so it should be 1 and everything would be 0 again. Okay, then DS with Bappy, so it should be 1 and everything would be 0. Okay, so here the number actually we got, this is for the D1, that means data 1, row 1. So here I can write like that. Let's I'll just simply write D1. Okay, D1 is equal to, so here I got one two-dimensional vector. So here 1 0 0 0 0. Okay, then comma 0 1 0 0 0, then comma I got 0 0 1 0 0. Okay, so this is my D1, that means sentence 1. Okay, this is for the sentence 1. Okay, I hope you clear. Now again you will take the sentence 2, that means D2. Okay, D2. Now you will just try to find the numerical representation. Now let's find the D2 as well. So let's say DS with Bappy. So again, let's say this one would be 1 and everything would be 0. Okay, so this is for actually D1, and now we are doing for D2. Now again it will see the watch. So watch is here, it would be 1 and everything would be 0 again. Now the next thing would be DS with Bappy again. So let's say this is a DS with Bappy and everything would be 0 again. Okay, so this is what actually your D2. So again I can represent like that. Let's say D2 is equal to 0 0 1 0 0, comma 0 1 0 0 0. Okay, then comma I'll take 0 0 1 0 0. Okay, so this is my D2. So that's how you have to complete for all the sentence. That's how you have to complete for all the sentence, and at the end you will get all the vector representation. Okay, you will get all the vector representation. I hope it is clear. Okay, how one-hot encoding can be applied. Now let's say you have completed for all the sentence and you got your vector. Now what you will do, you will just try to create a neural network. Now just see the input size. The input size for the model, you can see input size would be 1 2 3 4 5, because we are having 5 unique word only. So everywhere you can see 5-dimensional vector 1 2 3 4 5. That means you will be taking a neural network like that 1 2 3 4 and 5. Okay, inside that you will take some hidden layer and you will get your y hat here. Okay, so that means you will pass the data. Okay, you will pass the data in this particular layer. That means you will take this particular vector. So first of all you will do for the D1, you will take this particular vector, you will pass it here. Okay, then the second one you will pass it here, then the third one you will pass it here. Okay, that's how you will be passing for all the sentence. Okay, you will be passing for all the sentence. But let's say in case in your corpus, okay, in your corpus the number of unique word is 1000. Number of unique word is 1000. In that case, what should be the input size of the model? Definitely it will also become 1000s. That means you have to take 1-dimensional, sorry, 1000s neuron. Okay, at the very first. That means again complexity is increasing. Let's say in your entire corpus you are having 2000. Okay, 2000 unique word. So you have to take 2000s actually neurons. So if you're using one-hot encoding, that means the number of unique word you are having in that particular corpus, based on that your input layer would be decided. Okay, it's not a recommended, because if your input, if your let's say unique word is increasing, your neurons is also increasing, and whenever you are increasing the neurons, your calculation would be increased also, because at the end you are doing neuron calculation, you are doing the computation here, so computational cost will also increase, right? So that's why it's not a recommended way. Again, there is another issue. Let's say I'm having a sentence and which have actually the word which is not present in my corpus. Let's say I can write my name is Bappy. Let's say this sentence actually I'm having. Okay, now just try to see, these are the word is having in my entire corpus. No, these are the word is not present inside my entire corpus. Okay, that means what will happen, it would be out of vocabulary issue. That means the vocabulary you are having right now, it is not present inside your corpus. So your model won't be able to understand these are the word, because you haven't used this data during training. So whenever you are giving during testing, definitely it won't be able to understand what kinds of sentence you are giving. So again, it is called actually out of vocabulary issue, OOV. Okay, out of vocabulary issue. So if you're using one-hot encoding, so you will get this kinds of issue. Okay, out of vocabulary issue. And another issue I think you saw here, you are having lots of zeros. You are having lots of zeros. And zero is what? It's a sparsity problem. That means it's a sparse matrix you are having. Okay. And whenever you are doing the computation and whenever you are using zero, okay, to perform any kinds of operation with number, so there is no meaning, right? That's why zero is an unnecessary number here. Zero is unnecessary number here. So you are unnecessarily increasing the computation here because you can see zeros is increasing the dimension in this particular case. So let me just write some of the drawbacks of the one-hot encoding. So here I'll just write the drawbacks. So the first drawbacks, you can see the sparsity. That means here you are having lots of zeros. Then the second, you can see the no fixed sized, because anytime your sentence might be anything. Okay. Let's say here I have taken people watch DS with Bappi. I can take also my name is Bappi Ahmed and I'm a data scientist. Now just count of the sentence length. You will see that it would be bigger. Okay. So you can write no fixed size. Then the third you saw OOV, that means out of vocabulary issue. And the fourth important things, it is not capturing semantic meaning. Semantic meaning. Semantic meaning means after people watch is coming, after watch DS with Bappi is coming, before DS with Bappi watch is coming, before watch people is coming. These kinds of semantic information, semantic relationship, this is not capturing because it's just a number. And whenever this word is present, it is giving 1. Otherwise, everything it is giving as 0. That means this particular number is not capturing the semantic information of your sentence. But whenever we are using text data, so definitely it will have the semantic relationship. That means it will follow one grammar. What kinds of grammar? Let's say whenever I'm writing any kinds of sentence, let's say my name is Bappi. So my is a subject. So my is a subject, name is noun. Okay. Is verb. Bappi is also a noun. That's how it is following one grammatical rule. Okay. That means after my name will come, after name is will come, after is Bappi will come. Okay. So it is following one relationship. It is following one relationship like that, right? So these kinds of relationship, it won't be able to capture if you're using one-hot encoding. Okay. So that's why we can't use this particular method. Okay. We can't use this particular method whenever we want to convert our data to numerical representation. That means vector representation. Okay. Inside generative AI. So this technique you don't have to follow because it's like very basic technique. If you're doing any machine learning project, if you have some level of categorical data in a column, you can use this one-hot encoding there. But whenever you are working with completely textual data inside generative AI, I won't suggest don't use this particular method because I already showed you some of the drawbacks you will get here. So now the second technique we'll be discussing about bag of word. Okay, bag of word. Now let's try to see the bag of word example, like how it will work. So for this, I'm going to copy the same table. So again, you can consider the same things corpus. So I'm using the same table. That means it will have the same corpus. Again, the number of, let's say, unique word would be 5. And you have to create a 5 unique word table. So let me again copy. Now, how this bag of word will work? See, this bag of word will work based on the count. Okay, based on the count of the word present in your entire corpus. So let's say, first of all, it will see people. So now just try to tell me how many times people you can see in this particular sentence. I can see only one time. So people is coming only one time. Okay. Now the next word, watch. So how many time watch is occurring in this particular sentence? Only one. Then DS with Bappi, one time. And write is there? No. So write is not there. It would be 0. And comment is not also there. It would be 0. Okay. Then the next sentence you can see DS with Bappi, only one. DS with Bappi now occurring 2 times. So it would be 2. Then watch is occurring only one time, 1. And people is not there. Write is not there. Comment is not also there, right? Now the third sentence, people is coming one time. Write is coming one time. Okay. Comment is coming one time. And watch is not there. DS with Bappi is not there. Now the last sentence, DS with Bappi only one time. Write is only one time. Comment is only one time. DS with watch is not there. People is not there. Okay. So this is how actually you'll be generating the vector. Okay, this is how actually you'll be generating the vector. Now just try to match with your previous vector. What you have observed, you see the bag of word technique you have applied, it is having very less zeros than your one-hot encoding. Okay, that means it is slight better than your one-hot encoding. Okay, because it is working based on the counting. Okay, based on the counting. Okay, counting of the word present in the sentence. Okay, this is the idea. Now research proven, research already proven that if you want to do something called classification kinds of task, let's say sentiment analysis. Okay, sentiment analysis. Then let's say we are performing positive negative reviews. Okay, these kinds of tasks you can use this bag of word technique to perform the text vectorization, because this is suitable for this particular task. Because if you see any kinds of sentiment analysis problem, let's say here I'm having some sentiments, this movie is wow, or you can also write this movie is amazing, amazing performance. Okay, performance. Let's say these kinds of reviews you are having. Now if I want to find the positive, okay, positive or it's a negative, I can see the, let's say, word. So movie, amazing, amazing performance. Okay, you can see amazing, this particular positive was is occurring like multiple time. That time I can consider it's a positive review. Okay, it's a positive review. So that is why it's a frequency based actually approach. So it will always try to see the frequency count in a sentence, and based on that it will decide whether it's a let's say positive sentiment or whether it's a negative sentiments. Okay, so that is why it is recommended if you're performing any classification kinds of task inside a text, you can use this particular approach. Okay, but again, one drawbacks you will see, it is not capturing the semantic information, like after DS with Bappy, what is coming, after what DS with Bappy is coming, or let's say people, what is coming, after what DS with Bappy is coming. So this kinds of semantic information it is not able to capture. So again, it's a drawback. Okay, and some of the zeros still you can see. Okay, because again it will increase that your computational cost, because zero doesn't have any kinds of meaning if you are doing any kinds of operation, right? This is the idea. Fine. So apart from that, we are having some more technique we can follow, like we are having something called TF-IDF. So we are having TF-IDF. Then we are also having another technique called word-to-vec. So this one use one statistical, let's say, equation to perform let's say vectorization, and this one is the deep learning based actually vectorization technique. Okay, and from this technique actually lots of idea came how we can use the transformer model to perform the feature extraction, because whenever I'll teach you this word-to-vec technique, I'll show you the feature extraction technique. So how it will extract the features from a sentence, let's say from a text. Okay, so from here actually idea came, then people have actually launched transformer based actually encoding technique. That means with the help of transformer model you can perform the text representation. That means you can convert your text to vector representation, and whatever large language model you are using, okay, LLM, you'll be using this transformer based approach only to convert your data to the numerical representation. So whenever we'll do the practical, that time definitely I will show you. Okay, we'll be downloading the model from the Hugging Face. Hugging Face is also having lots of tokenizer. That means this kinds of encoding model. Okay, with the help of that we can easily convert our data to the numerical representation. Fine. So as of now, let me show you all the practical. That means that's bag of word, then TF-IDF, then word-to-vec. Okay, how we can use it and all. But before discussing TF-IDF and word-to-vec, I just wanted to show you this bag of word practical. So for this, what I will do, I will open up my Colab notebook, and there I'll show you this particular practical. So guys, here you can see I already prepared one Colab notebook for you. So one-hot encoding I'm not going to show you, because you already know how to perform one-hot encoding. So with the help of pandas library also we can perform one-hot encoding. Even we also have one, let's say, class inside sklearn library, okay, to perform the one-hot encoding. So I'm expecting if you already work with machine learning, you know how to perform one-hot encoding. And again, we are not going to use one-hot encoding technique in our analysis, but bag of word will be using sometimes, because I told you now if you are doing any kinds of sentiment analysis and all, that time you can perform, because it's easy to implement. Okay, at the end. Now see, bag of word, for this I need two library, NumPy and pandas. So let me import them. So with the help of pandas, actually, I'll be creating a data set first of all. So the same data set example I have taken, the data set I showed in my whiteboard. Okay. So you can see people watch DS with Bappy, DS with watch DS with Bappy. Okay. This kinds of example I have taken. Now let me prepare the data frame. Okay. So this is my data frame. And here I also have taken another, let's say, column called output. Let's say whether it's a positive, whether it's a negative. So that's how I've just given a number. Okay. It's just an assumption number as of now. Don't try to think it's an actual number. Fine. 1 means it's a positive. 0 means it's a negative. Okay, but whenever you will be using actual data, there will have the positive negative previews, okay, based on the text you are having. I hope it is clear. Now if you want to perform bag of word technique, you have to use one library called sklearn. From sklearn, you have to use something called count vectorizer. Okay, so count vectorizer is nothing but it's a bag of word technique. So I know that many of you already use this count vectorizer in your machine learning, but you don't know this is a bag of word. Okay, so now just try to remember it's a bag of word technique only, right? Now we have created the counter vectorizer object. Now here I just need to fit my data, and I want to fit my data on top of my text. That means textual data. Now here I'm fitting the data. Now it will return me all the vocabulary. Now see what will happen here. It will just assign some of the index number. Okay, it will just assign some of the index number with all the words. Now whoever having actually 0, that means this is the first index. That means this word would be considered at the very first. Then this one, that means number 1, then 2, 3, and so on, right? Now how it is generating this particular array, so let me just try to discuss. Now just try to see which word is coming at the very first based on the index comments. Now just try to see comment is there in the first sentence. No, comment is not there, that's why it is coming as 0. Got it? Now the second sentence you can see. Now the second word you can see, DS with Bappy. Now tell me, DS with Bappy is there? Yes. How many times? Only one time, that's why it's coming as 1. Okay, then the next one, people is there? Yes. How many times? Only one time. Okay, then the next word, watch is there? Yes, is there. How many times? Only one time. Then the next one, I think last one, right is there? No, right is not there, that's why it is coming 0. Okay, now let's consider the second sentence. Okay, now again you have to consider based on the index. Again, comments is there? No, comment is not there, so that's why it's 0. Now next thing, DS with Bappy, yes, it is there. How many times? 2 times, that's why it's coming as 2. Okay, then you can see the next one, people is not there, that's why it's coming as 0. Okay, it's coming as 0. Then after people, actually we are having watch is there? Yes, there. How many times? Only one time. Okay, then after that we are having something called this one, right is there? No, right is not there, that's why it's coming as 0. That's how you have to consider for all the sentence. I hope it is clear how it is generating this particular number. Okay, and this is your vector. Okay, this vector actually you can pass to the model. Okay, this vector you can pass to the model. So if you're only printing this bow object, see what you will get one object here. Okay, you will get one sparse matrix object, and if you want to get the number, that means the complete array, you have to use this particular method called toArray. That's why every time I'm doing this one. Okay, just to show you all the number. That is the idea. Fine. Now if I want to perform on top of my new data, let's say this is one sentence I've given, Bappy watch DS with Bappy. So I have to use this particular transform. Okay, transform function that time, cv.transform, pass your data and convert it to toArray again. You will see your data representation. Fine. Now what you can do, you can store your X and Y data. Let's say X is nothing but my entire bow, and Y is nothing but my output. So this is my output. Okay, positive or negative. Now you can pass this data to the model. Okay, this is the idea. Got it? Now there is another things inside bag of word called n-grams. Okay, what is n-grams? N-grams is nothing but here you see, n-grams is nothing but here you do the same thing, only you give one n-grams parameter. So let's say if n-gram parameter is 2, so what will happen? Let's say n-gram parameter is equal to 2. That means it will consider 2 word as a 1 token. Okay, 2 word as a 1 token. See, previously I took individual word, right? Now it will consider 2 word as 1 token. That means here it will come people watch. Okay, inside this box people watch will come, then watch DS with Bappy will come. Okay, so that's how you have to take pair of word. Okay, and you have to perform the same thing. So this is called actually n-grams. Now let's say n is equal to 3. That time 3 pair will come. That means 3 word you have to consider. Okay, but I saw that people are using only 2 parameter because sometimes it is required. So let me show you one example why it is required. So let's say here I'm having a review. Movie is very good, and here I can write it, this movie is not very good. Now this one is the positive sentiment, you know, this one is the negative sentiment, you know. Okay, but how about your model? Okay, how it will identify? Because I told you based on the frequency count it can decide. Let's say you are having some word, let's say very good movie. Okay, that means it's a positive one. And if it is coming to the second sentence, let's say this is the first sentence, this is the second sentence, again it can consider movie very good, and it will ignore this one because it's a stop word. I think I taught you the stop word concept, right? Not would be considered as stop word. So again your model will try to consider it's a positive. Okay, it's a positive review, but although it's a negative review. But how I can capture this negative information? So if I am doing this n grams, that means if n is equal to, let's say n gram parameter is equal to 2, it will consider 2 word as a pair. Okay, 2 word as a pair. So the first word, then second word, then this 2 word, and this 2 word. Okay, so it's a positive one. You can see now, you can see it's a positive one. So this movie very good. Okay, now again if I just make this sentence, let's say this word, this word, this word, this word, and this word. Now you can see easily it is capturing is not. Okay, is not. Now see, it is easily capturing this is not. That means not word as well. Okay, now easily your model can identify it's a negative. Okay, it's a negative sentiments. Okay, so that's why sometimes we have to perform this particular n grams operation. Okay, because if you're giving n gram parameter is equal to 2, that time it will consider 2 tokens. Okay, in one just let's say representation, and it can capture some of the hidden information. Okay, this is the idea. Now let's see the practical. So here you can see the same example only. You have to use the counter vectorizer. I'll convert to the text. Now see, whenever I used counter vectorizer, here I have given a parameter n grams range is equal to 2, that means it will consider 2 words. Okay, now you can see people watch DS with Bappy, DS with Bappy watch. Okay, now it is considering 2 tokens. Okay, in just one representation. That's the idea. If you give 3, so if you give 3 here, it will consider as a 3 word. Okay, 3 word as a count. Okay, that's how you can consider. Fine. And if you're using 3 word, that means it would be considered as a trigram. Okay, trigram. And this if you're using 2 words, if you're using 2, it would be considered as a bigrams. Okay, this is the idea. Now there is another technique I already showed you, TF-IDF, that means term frequency inverse document frequency. So this will work based on one equation, based on one, let's say, statistical equation. So simply in Google you can search for this equation TF-IDF. So you'll see this particular formula. So yes, this is the formula, guys, it use, okay, to perform this text representation technique. Okay, so it will work based on the, let's say, weight. Let's say if anyone word is having, let's say, frequent count, okay, in a sentence, it will give more weight. Okay, it will give more weight. Now if I show you the representation, so you have to use this sklearn to initialize TF-IDF vectorizer. Now inside that you can pass your data. Let's say text data I'm passing, I can name converting to the array representation. Now see, you are getting the entire array. Okay, now see, none of the number is 0, complete 0. You will still get some number. Okay, it would be a floating number. So this technique helps us to reduce that sparse matrix dimensionality issue, because if you are using 0, okay, 0 in your, let's say, vector, you are doing unnecessary computation. That's why it will assign the weights, and weight is nothing but it's a floating number. Okay, and everywhere you will see the floating number. So this particular issue will be resolved, because still after performing bag of word you are generating some zeros. But if you're using TF-IDF, you are not generating any kinds of zeros. Okay, so this is the main benefit here, and this is better than your let's say this one, bag of word. Okay, sometimes you can also use this TF-IDF technique. Again, I won't be recommended to use this one because we have some better option to do. Next thing I will be teaching you that word-to-vec technique. That means we'll be using deep learning model for the feature extraction. Okay, and this will contain the semantic information, because again, if you see this TF-IDF is not able to actually contain the semantic information. That means after, let's say, people watch is coming, after watch DS with Bappy is coming, this kinds of semantic information is not able to capture. Okay, so again, I won't be recommended to use this TF-IDF technique here as well. Fine. And here is the some TF-IDF value. Okay, if you are understanding this formula, you will get it. Okay, what kinds of things it is generating. But initially I won't be suggesting you to deep dive in this equation, because again it's not a recommended. We won't be using it. Okay, we'll be understanding whatever actually we need, okay, for our large language model. That's the idea. So yes, these are some actually practical I showed you for the text representation technique and word embedding technique. Now the next thing we'll be discussing about this one, word-to-vec technique. Okay, now let's try to see how word-to-vec technique works. Okay, So guys, now we'll be discussing about Word2Vec. So this is the deep learning approach actually. So how Word2Vec works and how it will extract the features from the data itself, I'll try to clarify. See, Word2Vec actually use two kinds of architecture. So if you want to see, just write Word2Vec architecture. So you will see it has actually two kinds of architecture called CBOW. So here you can see guys, it uses two kinds of architecture, CBOW and skipgram. So it's a neural network only, right? So let me show you the core mechanism of Word2Vec, like how it extracts the features. Let's say you are having documents. Let's say you are having an entire corpus. And in the corpus, let's say you are having some unique word. So let me create a table. So I can create a table, just a minute. So here I'll be adding all the features. And this side I'll be adding all the unique word. Let's say you are having the word of king. Let's say queen. Let's say man. Let's say woman. And let's say monkey. So as of now, just try to consider these are the unique word you are having in that particular entire corpus. Now how your Word2Vec will try to extract the features. So see, it's a neural network, and neural network works based on the back propagation, because every time it will adjust the weight, based on that it will learn. And if you see the neural networks, you can't see like what kinds of feature it is extracting, because it's a completely hidden thing. If you see for the, let's say CNN, if you see the for the NN, so these feature extraction things is a completely hidden. You don't know what kinds of feature it will extract. But as of now, let's consider it has, let's say, generated some of the features. Let's say the first features it has generated based on this word gender, because gender features can match with all the words you can see, because all the, let's say, word I'm having, let's say all the entity I'm having, it has the gender, yes or no, right? Then it has also generated another features, let's say wealth. Now you can see wealth is also matching with all the words. Now we can also consider power, then weight, then speak. See, as of now, I'm just assuming these are the features my model has generated, because here we're using deep learning model. I think I showed you. Now see, that's how actually it will identify the features. That means the vector representation. First of all, it will see king has gender or not. Yes, king has gender and it's a male king. Let's say male king. Queen has gender. Yes, let's say 0. 0 means female. Man has gender. Yes, 1. Woman. Yes, that means 0, because man I'm considering as 1 and woman I'm considering as 0, right? Monkey has also gender. Let's say 1. Now wealth, king has wealth. Yes, king has wealth. Let's say I can assign as 1, because king is having lots of wealth. Queen is also having wealth, let's say, because queen is a part of king, right? Man is also having wealth, but less than king and queen. So I can give, let's say, 0.5, okay? Or I can give, let's say, 0.2, fine, because again, they are king and queen, right? Woman has also wealth, let's say 0.2, less than man. Monkey doesn't have any wealth, I will give 0. Now power, yes, definitely king has the power. Queen also has the power, okay? But I can just decrease a little bit. Let's say less than king, okay, I can give 0.7. Man has also power, let's say 0.3. Woman has also power, let's say 0.2. Monkey, no, monkey doesn't have any power. Now weight, yes, king has weight, let's say I will give 0.8. Let's say this king is a little bit obese. Queen, yes, she has also weight, I can give, let's say 0.5. Very slim queen. Man, let's say 0.7. Woman, let's say 0.5. Monkey, let's say 0.3. Fine. King can speak. Yes, king can speak. Queen can also speak. Man can also speak. Woman can also speak. Monkey, let's say, can't speak. Okay. Now see, beautifully, I have generated some of the vector. Okay, beautifully, I have generated some of the vector. And I haven't generated, it has generated by your Word2Vec algorithm. Okay, Word2Vec model. That means this architecture, the deep learning architecture you saw. CBOW. Okay, CBOW and skipgram. Okay, so these are the architecture. Let's say it has generated these features. Now if I tell you, just try to give me the king vector. So what it will give me? It will give me, let's say, king is equal to, let's say this is the king vector. So I can write here 1, then 1, then 1, then let's say 0.8, let's say 1. This is my king vector. You can also give me the queen vector. So here is the queen vector 0, 1, 0.7. Let me just write 0, 1, 0.7, then 0.5 and 1. Okay, this is the queen vector. You can also give me the man vector. Yes, the man vector. 1, 0.3, 0.3, 0.7. 1, 0.3, 0.3, 0.7 and 1. Okay, then woman 0, 0.2, 0.2, 0.5, 0, 0.2, 0.2, 0.5 and 1. Then let's say this is the monkey vector. 1, 0, 0, 0.2, monkey 1, sorry, should be 1, then 0, 0, 0.3, 0, 0, 0.3, sorry, 0.3 and I think 0. Okay, see all the vector I got. Now if you plot them in a dimensional space, let's say this is my dimension. As of now I'm just drawing two-dimensional dimension, okay, because 3D 4D I can draw here, that's why I just consider two-dimensional space. Now here you can let's say this is your x coordinate, this is your y coordinate. Now let's say first of all I want to, let's say, represent king here. So let's say king is here. Let's say this is the king. This is the king vector. Okay, this is the king vector. I can write this is the king. Now if you just plot the queen also, you will see that queen will come close to king. Okay, queen will come close to king. Why? Because if you see the vector, okay, if you see the vector, they are very closely related vector. You can see, let's say if you calculate the queen distance with respect to all the vector, you will see that queen will have very less distance with the king because both are similar. Okay, both are similar. Okay, because you can see queen is the part of king, so all the features are already matching with the king. That's why it is coming to close. So that means it's a cluster. Okay, it's a cluster of king and queen, so they are falling in the same cluster. Now similar wise, if you plot the man and woman vector, you will see that they will come nearly. Let's say this is your man. Okay, man vector, and let's say this is the woman vector. Because if you see carefully, man and women vector, they are closely related. Okay, they are almost similar, so that's why they are coming in the same cluster. So again, it's a cluster, okay, for man and woman. And if you see the monkey, okay, monkey is a completely different entity. You can see the vector is also different. So let's say monkey will come here. So I can take a new pen. Let's say this is the monkey. Monkey, okay, and monkey, it is present in the different cluster. Okay, so that's how it is capturing the semantic information, okay, between multiple words. Now let's say there is another sentence you are writing. Let's say I am a princess. Okay, princess. Now tell me where this princess will come, in which vector, in which space, okay, in which cluster. It will come definitely inside this particular cluster, because if you just extract the features from the princess, you will see that it would be close to king and queen. Okay, so that's how this word2vec can actually understand the semantic information of a word. Okay, so that's why it is so that's why word2vec is the much better than your previous whatever technique you have learned so far. Okay, and from here actually your actual concept starts, like whatever things you will be learning in future. Let's say transformer based encoding, like how transformer model extract the features. That's how it extract the features. Okay, because at then it's a deep learning model, and by the backpropagation itself it will generate these are the features. But as a human you won't be able to see the features, but here we are assuming, let's say these are the features your model may create, and based on that, that's how it will generate the vectors embedding. Okay, and when it comes to semantic information, that's how it will let's say capture the semantic information, because it will plot all the vector in a dimensional space, and there it will try to find the relationship whether king and queen are same or not, man and woman are same or not, monkey is a different or not. Okay, I hope it is clear now. So let me show you one image actually, experiment of word2vec. You can see this is one experiment for the word2vec. So here you can see we are having three kinds of word: king, man and woman, and whenever word2vec is applying on top of it, it is generating some features. You can see, so this color represent the features. Let's say these are the features it has generated. Let's say this is wealth, this is power, this is speak, this is, and let's say this is the weight. Now you can see king color is different than your man and woman. Now see, man and woman color, they are closely related. You can see all the color is matching. Okay, all the colors are matching. That's how it is making a separate cluster of man and woman, and king is a different entity here. Okay, I hope it is clear now. So now let's see the practical of Word2Vec, how we can use Word2Vec in a Python code. So for this, I'm going to use one dataset. So let me show you the dataset here. So the dataset name is Games of Thrones book dataset. Okay, dataset in Kaggle. I think you know what is Games of Thrones. Okay, it's a series actually. So if you don't know, you can simply search on image. See, this is one actually series. Okay, this is a movie series actually, Games of Thrones, and it is having different characters. So if you have already watched this particular, let's say, series, you will know okay about this particular character and all. So based on this particular series, one book has been published, and this dataset is available in the Kaggle also. This book dataset. Now this book contains all the dialogue, okay, present in that particular series. Okay, see all the dialogue. It is having different txt file, you can see, based on the, let's say, season. Okay, it is having different dialogue from all the characters. So what I'll do, I'll just try to download one txt file, and I'll just try to apply Word2Vec on top of it, and I'll try to see what are the character are closely related. That means I'll see these kinds of, let's say, representation. That means whether some character are in the same cluster or not. Because if you see this series, some of the character would be closely related. Okay, let's say character 1, let's say character 2. They're similar kinds of character. So these two vector will come closely. Okay, that's how we want to see the relationship, okay, between the data. So I already downloaded one txt file. You can also download. Just try to search for Games of Thrones books in Kaggle. You will see this particular data. Just try to download one txt file. So let me show you the notebook. So guys, this is the notebook, and here we'll be showing you the Word2Vec. Now let me connect, and this dataset is already available in this link I have already given. Now let me download and let me upload in my Google Colab. So here I can upload this data. So I'll create a folder here called data, and inside that I can upload this txt file. Now first of all, let's import some library. NumPy, Pandas, and Gensim I'm importing because Word2Vec is there inside Gensim library. Okay, if you want to use Word2Vec, you have to use this particular library called Gensim. Inside that, you have the Word2Vec architecture. Now let me import them. Now, if you're using Google Colab, first of all, you have to update the Gensim because otherwise you will get some of the issue. So let me update. Okay, update is done. Now I'm importing like sentence tokenizer from the NLTK. And I'm also importing simple preprocess from the Gensim library because before passing my data to my, let's say, Word2Vec model, first of all, I have to apply some processing. Okay, processing means it will do some cleaning operation and all. Then you can pass the data. So let me import them. Now this code snippet will load your data from the data folder, you can see. Okay, so here I'm having test.txt, so it will load the data. And it will extract all the, let's say, word. That means all the sentence one by one, and it will perform the tokenization. Okay, it will perform the tokenization. That means every word will have the tokenizer. Okay. Now if I show you the story, that means story list. Now see, you got your all the sentence. Okay, see, this is the entire sentence, and inside a sentence you have done the word level tokenization. Okay, this is the idea. Now if you check the length of the entire story, you have more than 8,000 actually, let's say, example here. So here you are having more than 8,000 sentence. That means 8,000 dialogue. Okay. Now you can see the entire story. Now if you want to see the story 1, that means the first, let's say, dialogue, the first sentence, this is the first sentence. Okay. You can see. And again, we have done the word level tokenization. Okay. Individual token. Now we have to initialize the Gensim model. So that's how we can initialize the Gensim model. So let me initialize. Then if you want to, let's say, convert to the vector representation, just try to call this particular function build vocab. Now inside that, pass your data. Then you have to train the model. So you have to give your data, total example. Then total example, you will get total example from the model.corpus count. That means it will count the entire corpus and it will give the count. And you have to give the epoch. Okay, epoch, you can take the default actual epoch from the model itself. Now see, my training is completed. Now if I want to see the similar, so similar of Daenerys. So Daenerys is a character inside this particular, let's say, series. So see, she is the character. Now you can see the similar score of the Daenerys with these are the word. Okay, these are the word. But see, again you will get some, let's say, random output, because here we are only using one dialog, that means one txt file. I'm not using the entire txt, entire dialog, because unless and until my model is not getting the entire dialog, it would be a little bit difficult for it to match those character, yes or no, right? So if you're doing it, just try to take all the data and try to perform this job. But here, just to show you, I have taken only one txt file. Now you can see with still word, it is having 0.99 okay percent relationship, okay, linearize. Then and Prince, so Prince is another character, Prince in Games of Thrones. See, with him actually her character is matching. If you watch the series, actually you will see that with him her character is matching, okay, mostly. So you can see. Then Deny, then Dotarki also is a character. See, okay, so that's how we can actually match. Now see, it's not actually properly visible, so what I can do, I can also plot them in a, so what I can do, I can also plot them in a visual graph representation. I'll tell you, but before that, let me show you. If you want to, let's say, see the relationship between two characters, you can use this similarity function inside that give two characters, let's say Arya and Sansa. So if I give Arya and Sansa, so they are having, this is the relationship, okay. Now if you want to get all the vectors, you can execute this code. It will give you all the vectors, okay, all the vectors for the entire text you have given, okay, and the shape of the vector. See, now let me show you the visualization. I will apply the PCA, that means principal component analysis, to reduce the dimension. That means I want to plot in a 3-dimensional space right now. So here I'm initializing PCA component. Now PCA.fit, I'm giving my data, that means vector. So it will give me the 3-dimensional vector right now. That means from 100 dimension, it has reduced to 3-dimensional vector. I think you know what is PCA, principal component analysis in machine learning. We can use it to reduce the dimension size. Now you can see the dimension right now. So this is the dimension 3. And here we are having 3840 example in this particular entire text. Now see, if I want to plot it, I can use Plotly library. Now inside that, just pass your data and set the color. See, it will show you the entire representation of the data. See, that's how we are getting a 3D space. See, this is the 3D space. Now see the different word, okay, different word and their similarity. So here you can see they are closely related. These are the cluster. So this word is nothing but, so this red is nothing but, just try to see, it's a take, and this blue is nothing but, it's a put. That means put and take, they are falling in the same cluster because they have the relationship. Okay, if you just find in a grammatical way, you will see that they have the relationship. And apart from that, you will also see some character. Okay, you can also match the character. You will see that they are falling in the same cluster. So you can play with this particular graph. I'll share the notebook. You can play with this particular graph. See, that's how beautifully it has stored the data in the dimensional space. Okay, and that's how your model will identify, okay, the semantic relationship, okay, between two words. That means I showed you now here the semantic information from the word itself. I hope it is clear now. Fine. So yes, so that's how actually we can use this word2vec. And if you're using word2vec, you have to pass this particular data. Sorry, after this data, okay, the vector we are getting, the entire vector, that normalized vector, okay, and this is your vector representation. This vector you have to pass to the model. But again, we won't be using that. We have just learned this word2vec just to understand how my transformer architecture will be working, how it will extract the features, and how it will get the, let's say, semantic information. So in transformer architecture, you use something called attention mechanism, let's say attention model. With the help of attention model, it can actually understand the semantic information in a good way. Okay, this is a little bit advanced concept. Okay, that's the idea. So yes, this is what actually we can perform our data representation, that means text representation. And that's how we can perform the vectorization technique. So why we learned this? Because going forward, whenever we'll be learning about, let's say, large language model and all, before understanding large language model, I just wanted to let you know how data would be prepared for the model. Okay, now I think you got it, how we can prepare our data for the large language model. Okay, if I have any kinds of raw text, how we can convert to the numerical representation and which approach would be better. Because finally we saw that this word2vec approach is better because it is able to extract the semantic information. Okay, semantic information, because it is a deep learning model. Okay, this is the idea. So yes, I hope guys you got it. Now in the next video, we'll be using all the, let's say, topic we have learned so far, let's say text preprocessing and text representation technique. and we'll be doing one small project with the help of machine learning. We'll be doing one text classification project, which as of now we have learned about text preprocessing and text representation technique, like how we can convert our textual data to numerical representation. That means the vectorization, right? So we'll be using all the concept we have learned so far, and we'll be doing one hands-on. That means we'll be doing one practical. So here we'll be implementing one text classification model. So in this video, my main objective is to show you how we can prepare your dataset for the model. That means how we can apply all the preprocessing technique, how we can apply these kinds of text vectorization techniques so that you can use those data, okay, for the model training. But model wise, actually, I'm not going to use a large language model. As of now, I'm going to use simple machine learning model. Later on, I will also show you how you can use large language model. Okay, because it's the like very initial phase we are doing. As of now, we haven't learned about the LLM. That's why I'll be using simple machine learning model. So let's open up our Google Colab and let me show you the text classification practical there. So guys, as you can see here, I already prepared one notebook for you, and the dataset actually I'm going to use. So this is the link of the data. So the dataset name is IMDb movie review dataset. So this dataset is having 50k movie reviews. So you can download this data from the Kaggle. So Kaggle website, it is available. So it is having reviews based on the sentiment, whether this reviews is a positive or negative. Okay, so it's a classification problem statement. So I already downloaded the data. I have already given the link. You can download the data. So let me upload the data here. So I'll just try to upload. So this is my data. So here, let me upload it. Okay, my dataset is uploaded here. Now, the first thing what we have to do, we have to import some of the libraries. So here I've already listed down all the libraries you need for this experiment. So I need NumPy, Pandas, Matplotlib. Okay. Then I also need TenTestSplit, Counter Vectorizer, TF-IDF Transformer. Okay, so everything I have just imported here. And as of now, I'm not going to use this Keras. So let me just remove it. It's not required. So here I already told you I'll be using simple machine learning approach. So I don't need to use any kinds of deep learning library as of now. So fine, you can see guys, I have imported all the required library I need, and definitely I will explain whenever I will use it. I'll tell you, okay, why we're using this particular library. Now let me import all of them. I think NumPy and Pandas we already imported here, so I don't need it. I can delete it. Now you don't need to execute this line because here I have my data in my Google Colab. You can see Google Colab space. But if you have your data in your Google Drive, that case, what you can do, you can mount your Google Drive. So I'm not going to execute this line. So directly I'm going to assign my data path. So I'll copy, and here I'm going to mention the path of my data. Okay, so let's say this is my data path. Now I'll execute. Now I will load the data with the help of Pandas library. Now see guys, this is the entire data you are having, and here you are having the this one, your reviews as well as the sentiment of that reviews. Now if you want to see the shape, so here you are having 50,000 movie reviews and 2 columns. Reviews and sentiment. Now see here, I don't want to take all the data because again, if I'm taking all the data, it will take lots of time to process. So I'll only take the 10,000 example, okay, from this 15,000 example. So here you can see I'm taking only 10,000 example, first 10,000. And now you can see this is my data. Now if I show you the data shape, now see only 10,000 example I have taken. Now if you want to see any kinds of reviews, you can also check. This is the first reviews. Now, if you want to see the sentiment value count, that means how many sentiment it is having. It is having 2 sentiment, positive and negative. You can see. So positive sentiment is having around 5,000, and negative sentiment is having around. It is also more of around 5,000. You can see 4,972. That means it's a balanced data. Okay, we don't have any issue with the data. Now let's see whether it is having any missing value or not. For this, I can use isNull function. Now see, there is no missing value. Now let's see any duplicates is there or not. So you can see we are having 17 duplicates. What I can do, I can drop the duplicates. For this, you can execute this line of code, drop duplicates, and in place is equal to true. That means you want to permanently delete the duplicate. Now if I execute, now see, there is no duplicate data in my dataset right now. Now let's perform some basic pre-processing. So as I already told you, inside basic pre-processing, you can perform HTML, tags removal, then lowercase operation, stop word removal. So these are the things you can perform. Now see, from my previous notebook, that text pre-processing notebook, I have taken the same function, that removes tag function. That means it will remove all kinds of HTML tags from the data, because if I show you the data, it is having lots of HTML tags because it's a extracted data from the website, right? So let's apply this function. I will apply on top of the reviews. So it will remove all the, let's say, HTML tags. Now see, this is the clean data I'm having. Now see, there is no HTML tags present inside this data. Now the next pre-processing technique will be performing the lower casing operation. So let's perform it. So here you can see I'm applying lower casing. Now if I show you, see, all of my word has become lowercase right now. Fine. Now what we'll be doing, we'll be removing the stop words, because as I already told you, so stop word doesn't have any kinds of meaning in a reviews whenever you are performing any kind of sentiment analysis, because it will see the positive and negative words, okay, to differentiate whether this sentiment is a positive or negative. So here you can see here I've written a lambda function. So it is doing the same thing. You can also use the previous function I showed you in that notebook. Either you can also follow this particular approach. Okay, so here I'm using lambda function, and lambda is a one line function. Okay, in the one line I'm taking all the word one by one, and if any stop words is there, okay, I'm just trying to remove that stop word with the empty space. That is the idea. Now let me execute. Now see, there is no stop word present in this data right now. Fine. Now let me show you my head of the data. Now what I have to do, I have to just separate out my X data and Y data. That means my independent variable and dependent variable. So independent variable means this is the review one, and dependent variable means this is the sentiment. That means this sentiment is my label right now. So I'll store inside X, and label I will store inside Y. Now this is my X. That means the entire review, and this is my Y. That means my sentiment. Now one issue you can see, sentiment is nothing but it's a text. Okay, it's a text. You can see it's a string, but what I have to do, I have to convert to the numerical representation. So here I can simply apply label encoder. So it will assign positive with 1 and negative with 0. So let me apply. So for this I'm using label encoder from sklearn, initializing the object, and I'm feeding my Y data. Now see, your data will become 0 and 1. Okay, that means it has converted to the numerical representation. Then what I have to do, I have to perform the 10 test split, because I have to keep my data for my training as well as the testing. And the test size is I have given 0.2. That means 20% data I'm keeping for the testing and 80% data I'm keeping for the training. So let me perform. Now this is the training size and this is the testing size. Fine. Now I'll be applying first of all bag of word. Okay, I already taught you the bag of word. I think you remember. So I can use the counter vectorizer for this. Now I have to apply the bag of word on top of my reviews. Okay, reviews is my like input data, right? Then I'm also performing on top of my test data, because I'm having two kinds of data, training data as well as the testing data. And I think you know, whenever you are performing on top of training data, you have to use feed transform. And whenever you are performing on top of a testing data, you have to only use transform, okay, math function for this. Then I'm converting to the array representation. Now this is my training vector. And if you want to also see the testing vector, this is your testing vector. Okay, now here we'll be using one machine learning model called naive Bayes. Inside naive Bayes, we're having one naive Bayes version called Gaussian NB. Okay, Gaussian naive Bayes. We'll be using this particular algorithm. So here you can see I'm feeding my data, so X-train and Y-train. Now let me train my data. So here I'm only showing you how we can pre-process your data, how we can prepare your data for the model training and all. But going forward, here we'll be using actually transformer based architecture. Okay, that means large language model we'll be using here. Now this is the training I have done. Now we'll be doing the prediction on top of my test data. Then we'll be calculating the accuracy score. Okay, now let me execute. See, this is the accuracy score I'm getting if I'm using Gaussian NB and if I'm using bag of word. Okay, bag of word technique. So I'm getting 63% accuracy. Now you can see this is the confusion matrix. Now if I'm applying random forest classifier on top of it, so now let's see the accuracy I got. So guys, you can see after applying random forest classifier and I was using bag of word, I'm getting this accuracy, 84% accuracy. Now see, we'll be using bag of word only. Now instead of taking all the features, what I will do, I'll take maximum features 3000. Okay, now you can ask me what is maximum feature 3000. I think you saw the entire corpus, right? I already told you the corpus. Okay, about the corpus. Corpus means the entire data. And from the entire data, I'm only considering 3000 unique word. Okay, 3000 unique word, 3000 frequent unique word. Okay, this is called maximum features. Because see, I don't need all the features, because if I'm using all the features, my dimension will increase, right? And I don't need to increase my dimension. Okay, if my dimension is increasing, that means my model will get more complexity, right, to perform the prediction on top of it. And here I'm using a machine learning model. Okay, I think you can see. So that's why I'm taking most frequent 3000 maximum features instead of taking all the features, right? Now it will create 3000 dimensional space. Okay, 3000 dimensional space instead of taking all the unique word, right? Now see, again I'm performing the bag of word operation. Now again I'm taking random forest classifier and I'm training and checking the accuracy. Now if I execute, so you can see this is the result, but this result is not good enough. So we are getting closely related accuracy only if I'm using all the, let's say, features, and if I'm taking 3000 features, the accuracy I'm getting, it is almost same. Now let's try with n-grams, because I already told you about n-grams, right? What is n-grams exactly? So here let me pass the range of 2 to, because I want to consider a pair, okay, pair of word. That's why I have given 2 to. That means it will consider 2 word, okay, as a one pair. That's the idea. And here I'm only taking 5000 most frequent word. Okay, now again I'm performing bag of word operation, then random forest classifier, then I'm calculating the accuracy. Now let me show you. So guys, you can see this is the result actually I'm getting. So now in the summary you can see your like bag of word is working fine instead of taking the n-grams. So in some case actually bag of word will work fine, in some case n-grams will work fine. It's completely experimental things, okay, you have to perform. Now let's try with TF-IDF, okay, TF-IDF technique. So here is the TF-IDF code, I think you remember. So first of all we have to initialize the TF-IDF, then I will apply on top of my data, okay, training data as well as the testing data. So it will give me the vector, and again I'll be using random forest classifier to train the model, and I will show you the accuracy score. Now see if I show you the accuracy. So here we are using machine learning model, that's why performance is not good. But if you're using any kinds of deep learning model, you will see that your model will perform good. Now here you can see this is the performance of the, now you can see this is the accuracy I got. So here I showed you almost all the vectorization technique we have learned. But one thing I want you to explore, this word2vec one. So I already shared you the code of the word2vec. So what you have to do, just try to apply word2vec, get the vector and try to train with random forest model and just observe the accuracy. Okay, so this should be your task guys from my side, because unless and until you are not doing anything, things would be much difficult for you to learn, right? But if you are practicing by yourself, I think this will help you a lot to learn any kinds of topic. So yes, this is how actually we can perform the text classification with the help of machine learning. And that's how actually we can perform the data cleaning task like data preprocessing and text representation. Okay, everything we can perform like that. But again, I'm telling you guys, this is not an actual way we create our application. This is just a basic introduction I have given, like how we can like do the data preparation. Okay, this is my main objective. Now in the next video, we'll be learning about large language model, like what exactly this large language model and how this large language model got trained. Okay, everything we'll be trying to discuss. So as of now, we have seen so many things, like we saw the entire generative AI pipeline, we saw the text pre-processing as well as the data representation. And I also did one practical. I just implemented one text classification with the help of machine learning model. But I already told you, see, it was just experiment, but going forward, actually, we have to use something called large language model, because here we are learning generative AI. And inside generative AI, the core component is the large language model. Now let's try to understand what exactly the large language model is and what is the code architecture behind this large language model. So guys, as you can see, a large language model is a trained deep learning model that understand and generate text in a human-like fashion. Okay, LLMs are good at understanding and generating the human language. As I already told you, inside generative AI, we're having large language model. We also call it as a generative model. And what is the use of generative model? Generative model can generate a new data. Okay, so that is why here I have mentioned a large language model is a trained deep learning models that understand and generate text like a human fashion. That means whatever model you used previously, let's say whatever traditional model you used, let's say machine learning model, it can be any kinds of traditional deep learning model. Those are the model can't generate the text like a human fashion. Okay, it can only do the prediction, because I told you the difference between descriptive model as well as the generative model. But here this large language model can generate a text, okay, and it would be human fashion. That means the way human generate any kinds of text. Let's say currently I'm speaking, right? I'm giving you the understanding. So the same concept can be applied in the large language model also. So large language model can also mimic the human behavior. Okay, this is the main idea here. And LLMs are good at understanding and generating the human language, as I already told you. And how this LLM works, see the core working mechanism inside LLM, it will generate the next word. So here I've given an example. Let's say the garden was full of the beautiful. Now see, this particular sentence you are giving to the large language model, okay? And large language model is able to generate flowers. That means it is trying to generate, okay, next word always. Okay, it is trying to generate next word. That is the main core idea inside large language model. That means whatever, let's say, prompt we are giving, okay, whatever prompt we are giving, whatever, let's say, text it is generating, it will try to generate the next word always. Okay, this is the main logic behind the large language model. So here are some more example. You can see it's raining cats, and so this is my, let's say, input to the large language model. Large language model will try to actually generate this particular word called dogs. Okay, now there is another one. I have 2 apples and I ate one. I'm left with. So this is the input you are passing to the large language model. So PAL means nothing but it's a large language model, and it is able to predict 1. Okay, that means it is able to generate the next word of the prompt you have given. Okay, this is the main working mechanism of a large language model. Apart from that, there are some more advanced technique it usually used. I will also explain. So I'll also explain like how ChatGPT was trained and how it is working and all. Okay, I think this concept would be more clear. As of now, this is the high level understanding I'm giving you how this model is working. Okay, let's say whenever it is generating something new data, how it is working. This is the main idea here. Now let's try to understand why we call it as a large language model. Because you can see, because of the size and complexity of the neural network, as well as the size of the dataset that it was trained on. That means if you see any kinds of large language model, okay, over the internet, any kinds of LLM model, you will see it is using very big and complex neural network. Okay, very big and complex neural network. Even it is trained with massive amount of data. Okay, and the model actually we are using, it is called actually pre-trained model. That means this model is already trained with massive amount of data. Okay, it is called pre-trained model, and we call it as a transfer learning. I think you have already learned transfer learning in your previous days, right? In deep learning, computer vision, machine learning. So what is transfer learning? Transfer learning means we are using an existing model. Okay, that model is already trained with some kinds of data set. Okay, this is called actually transfer learning. So here, so this transfer learning makes this generative AI so powerful because they are training these kinds of complex neural network with the massive amount of data set. So as you can see, researchers started to make this model large and trained on huge data sets that they started showing impressive results, like understanding the complex natural language and generating language more eloquently than ever. Okay, this is the main idea. That's why we call it as a large language model. Now you can see the large language model core architecture. Now many people has this kinds of question. What is the architecture actually LLM is using? Okay, see, this is the core architecture all kinds of LLM are using. A large language models are based on the transformer, a type of neural network architecture invented by Google. Those who have already learned about natural language processing, right? Those who have already learned about attention mechanism, transformer. So you are already familiar with this architecture, yes or no, right? So you are already familiar with this architecture, and this architecture is known as transformer architecture. Okay, and it is invented by Google. Okay, and this was the main breakthrough in the field of natural language processing, even in the field of generative AI, because based on this particular architecture, all kinds of large language model you can see over the market. Okay, everything has been developed. Fine. So this is the main architecture here. So it is having two kinds of part. One is the encoder part, another is like decoder part. And inside that you are having something called multi-head attention. Okay, no need to worry. I will explain this particular concept. I will create a dedicated video for this. How this transformer architecture is working inside our transformer architecture, what are the component it is having. Okay, everything I'll try to clarify. Okay, for this I'll keep a dedicated video. Okay, so that you can understand this transformer in depth. Fine. As of now, just try to consider this is the core architecture behind all kinds of large language model. Okay, and it is invented by Google, and this is known as transformer architecture, and it is having two layers called your encoder layer, and this is like decoder layer. So this one left side, this is called encoder layer, and right side this is called decoder layer. Okay, inside that you can see different component like input encoding, multi-head attention, add normalization, feed forward. Okay, that's how you are having different component inside that. I hope it is clear. Fine. Now on top of this architecture, what they did actually, they added some more layer, they added some more functionality, and they brought this kinds of large language model, different large language model. Now let's try to see some large language model. But before that, first of all, let me tell you what makes large language model so powerful. Because I already told you, in case of LLM, one model can be used for whole variety of tasks. Like you can perform text generation, chatbot, summarization, translation, code generation, and so on. With one model, you can perform all kinds of tasks. But whenever we used to use our traditional NLP model, that means only the language model, we can only perform one specific task. Let's say you want to do language translation. For this, you have to only use language translation model, and that model can't do the code generation. Okay, but here in the large language model, you can do whole variety of tasks. I think you saw the chat GPT. Let me show you one example. So guys, this is our chat GPT. Now inside that, I can give any kinds of input. Let's say I'll give me the German translation of this text. Now here you can pass the text. Let's say, how are you? Fine. Now see, if I give this prompt, so it will give me the translation in German of this text. Okay, now see, this is the translation in German. Now I can also do the sentiment analysis. So here I can write, give me the, let's say, sentiment, okay, of this text. See, it's a neutral sentiment. Now we can also perform something called language detection. So I'll give me the language, or I can write detect the language. Okay, detect the language of this text. Now see, it should give me English. Fine. So that's how, with the help of one model, you can do variety of tasks. You can also generate the code. So I'll give me a Python code for adding two numbers. See, it can also generate the codes. So this is how actually large language model works. Okay, and that makes LLM so powerful. Now let's try to see some of the large language models are available over the internet. See, I've just listed down some of them, but you will see thousands of models are available. I will also tell you where you will get all the model list and all. Okay, so as of now, just try to see, guys. We are having different large language model like Gemini. So I think you know Gemini, right? Gemini was developed by Google. Even we are having also one application of the Gemini. Let me show you. So in Google, if you search for gemini.google.com, so you'll see this kinds of application, and this is the same kinds of application like your chat GPT. Okay, here also you can give the prompt, and here also you can get the response. Let's say the previous prompt I have given here, I can also pass it here. Okay, and in the backend they're using something called Gemini model. Okay, Gemini large language model. Then we're having something called GPT. Okay, GPT stands for Generative Pre-trained Transformer. Okay, the model was developed by OpenAI. That means the chat GPT you are using, it is using something called GPT based model. Okay, we are having GPT 3, 4. Okay, these are the model we are having. Even recently actually GPT published one amazing model, I think GPT 4o model. Okay, with that you can also generate videos. You can also generate like so many things. Okay, if you just search on Google, you will see different version of the GPT even there. Application and all, like, okay, everything you can see there. Then we're having something called XLM, that means cross-lingual language model. Okay, so this is one of the large language model. It is also available. Now we're having something called Llama. Okay, and it was developed by Meta AI. So Llama is having different variant like Llama 2, Llama 3. Okay, recently Llama 3 was published, 3.1 is published, I think. And this model is amazing. It can also, let's say, generate text like a human. Even going forward, we'll be also learning how we can use Llama 2, 3 model, okay, in our application. With the help of that, we'll be building different application. Now you can see there is another model called Megatron. So Megatron is a large language model, and it's like very powerful transformer model, okay, developed by NVIDIA research team. I think you know NVIDIA. So we are using NVIDIA GPUs in our system, right? So NVIDIA team has developed this particular Megatron model, and this is one of the large language model. Now we're having something called M2M 100. So this is called actually multilingual encoder and decoder sequence to sequence model. Okay, and it was developed by Facebook. So these are the models actually we are having. Apart from that, I told you now we are having thousands of models. Let me show you. So this is the GitHub, guys. So the GitHub name is OpenLLMs. Okay, now what this guy did, actually this guy actually listed all the large language models are available over the internet. Okay, now see, he has created one beautiful GitHub repository, and in the readme file he listed down all the large language model as well as their checkpoints. Let's say you want to download this model, you can also download this model from this particular link. If you want to read the papers and blog of this particular model, he has also given the link. Apart from that, the parameter size, context length, and as well as the license. So every information you will get of any kinds of large language model. Now see, T5 is one of the large language model, then RWKV4, okay, then GPT Neo X, then YAML, UL2, Bloom, Chat, GLM, okay. Now see, different large language model you are having, see, okay. Falcon is also there, then Llama 2 I already told you, then Mistral is also there, okay. See, different large language model, and it is having so many large language model, guys, so many large language model. If you want to export, open this particular link, just write open LLMs inside Google, you will be able to see these kinds of GitHub, okay. And you can also keep this link with you, so that if you need any model later on, if you want to develop any kinds of projects with the help of any kinds of large language model, you can use this repository later on, so that you can see the paper blog link, okay. It will help you to understand this particular model. So guys, as I already told you, all the large language model using one core architecture, which is nothing but transformer architecture. And inside transformer architecture, I showed you there are two kinds of layer called encoding layer and decoder layer, okay. Now see, here is the transformer architecture, let's say, and it is having two kinds of part, like encoder and decoder. Now I think I showed you different large language model, like thousands of large language model. Now see, all the models are not using both layer, that means encoder and decoder layer. Some of the models are using encoder layer, some of the models are using decoder layer, okay. And some of the models are using both layer, that means encoder and decoder both. Now here I've listed down some of the models, so this will give you the idea of what kinds of models are using encoder layer only, what kinds of models are using decoder layer only, and what kinds of models are using both layer. Okay, you can see encoder based architecture, these are the encoder based architecture like DistilBART, BART, Robata, okay, XLM, then Albart, Electra, okay, then DBARTA. So these are the model based on the encoder layer only, okay. Now you can see the decoder layer model. So GPT, GPT-2, GPT-3, okay, whatever GPT series you are having, it is using something called decoder layer only, okay, decoder architecture only, fine. Then both actually layer, that means encoder and decoder both layer. So we are having something called T5 BART, then we are having something called, see, this is BART actually, B-A-R-T, not B-E-R-T, okay, this is another model. Now M2M100 and Big BART. So these are the models are using encoder and decoder. See, it's not possible to list down all the models here, that's why I just listed down some of them, but there are so many models that are using like both architecture. There are so many models that are using only encoder architecture, there are so many models that are using decoder architecture, okay. And this is called actually transformer T, okay, this is called actually transformer T. So so by referring this particular T, you can easily understand what kinds of models are using which kinds of architecture, okay. This is the main idea here. Now let's try to see some OpenAI based large language model, because going forward we'll be using something called OpenAI platform, okay. We'll be generating OpenAI key and we'll be implementing different projects. Now see, inside OpenAI we're having different models like GPT-4, then GPT 3.5, GPT based, DALL-E, Whisper, embeddings model, even moderation model, GPT-3 legacy model. So these are the models that are available in the OpenAI platform. Apart from that, I think recently they have released more model, because it's a continuous research field. It's not like that it will be like fixed research. Every day they are bringing new technology in their platform, okay. So if you want to learn all of them, you have to keep updated with their technology always. For this, what you can do, you can refer their website, okay. You can refer their website and try to see what are the models they are bringing, okay. So like that actually you will be learning a lot. It's not like that you only need to rely on your mentor, okay. As a mentor, I can give you the entire path how you can get started with. I will teach you how you can use them, but as a learner, what you have to do, you have to explore by yourself. Unless and until you are not exploring by yourself, it would be very much difficult for you, okay, to learn any kinds of topic. So that should be my suggestion. Please try to explore from your end. After this actually video, what you can do, you can search OpenAI, you can search different open source website, and you can see what are the models are came actually recently, okay. That's how actually you can learn. And you can also create a GitHub repository like that, and you can list down all the models, okay, you will be exporting, okay, in future. That is the idea. Now let's try to see some other open source large language model. See, there are two kinds of large language models are available. One is like commercial model. Commercial model means this is the commercial model, like OpenAI based model. So if you want to use these are the model, you have to pay, okay, you have to pay. You have to take the subscription, okay. But if you're not interested in paying, what you can do, you can use open source large language model. So these are the models that are available in the Hugging Face platform. So if you're using these are the model, you don't need to pay, okay, freely you can access. But there you will get some difficulty, because these are the model you have to download manually in your system, You have to set up everything. Okay, let's say you want to fine tune this Mistral. What you have to do, you have to download the Mistral model in your system. Now just try to see what is the size of the Mistral model. Okay, more than 30 to 40 GB. Okay, so you should have good actually resources in your system. Let's say you should have good CPU, good GPU, good memory. Otherwise you can ever train this particular model. But if you're using commercial model, okay, let's say you are using OpenAI model. Okay, that time what you can do, you can use their platform like OpenAI platform to fine tune this at the model. Okay, you don't need to download this at the model in your system. So going forward, I will teach you how you can use a commercial model as well as the open source model both. Then you can decide which one you will be using. Okay, it's up to you. Now these are some open source large language model like Mistral, Llama, Gemini, Falcon, okay, Cloudy, then MPT 30B and Stablem. Okay, these are the models actually we are having as an open source model. Apart from that, there are so many model. I will tell you. There is a platform called Hugging Face. Inside Hugging Face, you will see all kinds of large language models are available there. Fine. What can LLM be used for? I already told you, you can use large language model for the text classification, for the text generation, for text summarization, conversation like chatbot, question answering, speech recognition, speech identification, spelling correction, and so on. That means whatever task you can see in the field of natural language processing, okay, all kinds of tasks you can perform with the help of large language model. Only one model. I think I showed you one example of the ChatGPT. Now there is another concept you will be getting inside large language model, which is nothing but prompt engineering and prompt designing. Now you can ask me what is prompt engineering and prompt designing. So you can see all the text that we feed into an LLM as an input, it is called actually prompt. And this whole art is known as prompt designing or prompt engineering, which is about figuring out how to write and format prompt text to get LLMs to do what you want to do. Okay, that means whatever input you will be passing inside large language model, okay, this is called actually prompt. And the way actually will be giving the prompt, the way actually will be preparing the prompt, this is called prompt designing or prompt engineering. Okay, now let's say here two example I have kept. It's raining cats and okay, let's say this is your prompt. You are giving this particular input to the large language model and your large language model will try to predict dog. I think I showed you. Okay, that text word generation. Okay, next word generation. Then I have another example. I have 2 apples and I ate 1. I left with, this is the input. Now your model will try to generate 1. Okay, now apart from that, we are having some types of prompt like few shot prompt, 0 shot prompt. Okay, these are the types of prompts are available. Let me show you. So this is called actually 0 shot learning, 0 shot prompting. That means here you are only giving the, you can see the approach using a single command to get an LLM to take on a behavior. It is called actually 0 shot learning. That means you are only giving a input, and your large language model will give you the output. Let's say this is your prompt, write me a poem about Ada Lovelace in the style of Shakespeare. Okay, this is the input. Now there is another one, explain the quantum physics to me like I am 5 years old. Now you are giving this prompt to the large language model and large language model is generating the response for you, the answer for you. Okay, this is called actually 0 shot learning. Okay, 0 shot learning. Now there is another learning called few shot learning. In few shot learning, in addition to just providing an instruction, it can be helpful to show the model what you want by adding the example. It is called actually few shot learning. So in few shot learning, what you will do, you will give some example. Okay, the prompt actually you are giving. Let's say here you are giving a prompt, convert the text from English to French. So with this prompt, you will pass some example like English to French example. Let me show you. So let's say this is the few shot from example. Let's say this is the prompt you are giving, convert the text from English to French. Now you are giving English as well as the French, English as well as the French. Okay, that means you are passing some example. Okay, instruction as well as the example, and your model will try to give you the response. Okay, after that means you are teaching your model how you're expecting the results. Okay, this is how actually you can pass the few shot learning or few shot prompting inside large language model. Okay, so going forward we'll be also learning this thing, how we can add our system prompt, how we can add the user prompt. Okay, how we can give few shot actually prompting, how we can give, let's say, 0 shot prompting. We'll be learning whenever we'll be using large language model. And always try to remember, if you want to get a good response from the large language model, you have to go with the prompt engineering and prompt designing. This is the main idea here. So yes guys, this is all about our large language model, okay, which is LLMs. So I hope you got the clear cut understanding about large language model, what exactly large language model is and what is the core architecture it is using in the backend. So in the next video, I'll try to explain that core architecture, the transformer architecture, how transformer architecture works, and what are the components are available inside transformer architecture. So here we'll be discussing one amazing research paper called Attention is All You Need. So this research paper published by Google, and Google actually brought this particular research called transformer. So here is the research paper, guys. Attention is all you need. If you are interested, read this particular paper. What you can do, simply search by this name. You will get this research paper. You can see this is from Google Brain. Okay. And you can see this is the architecture, transformer architecture. But I know that first time it would be a little bit difficult for you understanding this architecture from this particular paper. So what I will do, I'll just try to break down this actually architecture, and I will discuss each and everything, all the components, like what is input, encoding, like what is multi-head attention, what is add normalization. Okay, everything I'll try to discuss. Okay, then this part would be more clear. Then once we got the understanding, then if you come to this paper, this would be very much easy for you to understand this architecture. Okay, like how they have let's say created this architecture. And if you're interested learning the mathematics behind it, you can go through this paper. Okay, if you want to deep dive into this, you can go through the paper. It will give you the comprehensive idea. Now to explain this actually transformer, let's say concept, I'm going to refer one amazing blog by Jay Alamar. Okay, so this is one of the amazing guy, and he has created so many content related actually NLP. So this is one of the best resources you will find over the internet if you want to understand the transformer architecture. So this guy actually used so many visualizations, so many images to explain this architecture. Okay, so we'll be referring this blog to understand the entire architecture. I could have written everything on my Blackboard, but I thought if I show you the visualization, it would be more, let's say, good than the writing on my Blackboard, right? So if you want to understand this transformer architecture, so what I feel like this is going to be one best resources for you, because it is having so many visualization. Okay, we can easily understand what is happening inside transformer architecture. So now guys, let's try to understand this architecture. Now let's say this is your transformer architecture. As of now, just try to consider this is a black box. Okay, it's a transformer architecture and you don't know what are the component it is having. So here you are giving one input data. Okay, and you are getting one output data. That means you are performing language translation operation. So here you are passing this French input and you are getting English output. Okay, this is the idea. Now let's try to see what inside this particular transformer. Okay, transformer block. Now see, inside transformer block you are having two kinds of layer. One is the encoder layer and another is the decoder layer. As I already told you, transformer architecture is having two kinds of layer. One is encoder layer, another one is decoder layer. Now you are passing the input. Okay, you are passing the input to the encoder layer. See, this French input you are passing to the encoder layer, and the output you are getting, that English translation you'll be getting from the decoder layer. Okay, this is the main idea. Now let's try to break this encoder and let's see what are the component we are having inside encoder layer. Now see, if I show you this entire architecture, okay, in a low level, now you can see inside encoder we are having some more encoder layer. Okay, we are having some more encoder layer. How many encoder layer? You can see 1, 2, 3, 4, 5, 6. That means 6 encoder layer we are having. And how many decoder layer we are having? Again, we are having 6 decoder layer. That means the architecture you can see here. Okay, the box you can see here, encoder box and decoder box. Inside that you are using 6, okay, 6 stack of encoder and 6 stack of decoder layer. Okay, and inside that your input is going and it is processing this input and you are getting the output. Okay, this is the, so that's how this architecture consists of. Okay, I hope it is clear. Now let's try to see what we are having inside the encoder layer. Okay, now if I show you the encoder layer, see, inside encoder layer we are having two kinds of layer. One is like self attention, other is like feed-forward neural network. And what is feed-forward neural network? I think you know. That means the artificial neural network. Okay, if you're already familiar with ANN, you know what is feed-forward neural network. Okay, it's a artificial neural network at the end. Now let's try to understand the self-attention, because I know that many people will have the confusion what is self-attention here. Okay, now let's see. Now we can see this is the encoder. Inside encoder we are having self-attention as well as the feed-forward, and inside decoder also we are having self-attention, and another actually additional layer we are having which is called encoder and decoder attention, and the last layer you are having which is nothing but feed-forward neural network. So this part we'll be discussing later on. As of now, let's try to discuss this encoder layer and this self-attention part. Okay, now let's say you are passing the French input. You can see this is your French input. I don't know how to spell them, but just try to consider this is your French input. So the first thing what you have to do, the first thing you have to perform the text pre-processing, then text representation, yes or no. So here first of all you have to convert your textual data to the vector representation. Okay, so based on the paper they are using something called Word2Vec technique to perform the text representation technique. That means they are converting their text to vectors with the help of Word2Vec technique. And what is the dimension? Okay, what is the dimension of the vector? They are getting 512 dimension. Okay, 512 dimension for the each of the vector. Okay, this is the idea. Now let's say they have converted to the vector representation. Now what they are doing, they are passing this particular input to the self attention layer. You can see they are passing the input to the self attention layer. Self attention layer is giving one output, which is nothing but Z1, Z2 and Z3, and this Z1, Z2 and Z3 will pass to the feed forward neural network. Okay, now let's try to understand how it is encoding. Okay, how it is encoding this particular input. Now see, to simplify this particular understanding, what JLMR is doing, he is using two words actually, which is nothing but thinking and machines. Okay, let's say you are having two words, thinking and machine. First of all, what you have to do, you have to convert this text to vector representation with the help of word to vec. And what dimensional vector you will be getting? 512. I think I showed you here, 512 dimensional vector it will return. And this vector will be passing to the self attention layer. Self attention layer will give you Z1 and Z2. Then it will be passing to the feed forward neural network. Again, feed forward neural network will give you some of the output, and that output again you will pass to the encoded 2 layer. That means I showed you now we are having stack of the encoder layer here. See, stack. That means after getting one output from one encoder layer, it will go to the another encoder layer. Then again it will pass to the another, then another, then another. That's how we have to. That's how actually it will pass through 6 encoder layer. Okay, so that is what actually he is explaining here. You can see. So here you can see after one encoding, it is passing to the second encoding layer. Okay, this is the idea. Now let's try to understand what we are having inside self-attention. Now see, self-attention at high level. Let's say here we are having a sentence, the animal didn't cross the street because it was too tired. Now here just try to understand, the animal didn't cross the street because it was too tired. Okay, it was too tired. Now who was too tired here? Okay, definitely the animal was too tired. Yes or no? So as a human actually we can understand, it means this is the animal. It is indicating the animal. But what about the machine? How machine will identify whether this animal is the it or not? Okay, so for this it use something called self-attention. Okay, self-attention mechanism. Now let's try to understand how it will use that particular concept. But before understanding self-attention, just try to see how it will give the self-attention to the word. Let's say here you are having the input. So this is the input. The animal didn't cross the street because it was too tired. Okay, now whenever I'm referring this it, now here what it represents, definitely it represents the animal. Okay, you can see this darker color. That means it is more focusing on the animal part. Okay, the animal part, because the animal is nothing but it. Okay, that means your machine will try to understand, okay, if I want to consider it, I have to give the weightage to the animal didn't. Okay, these are the actually what. Okay, even two also. Okay, too tired also. These are the what it has to give the attention. Okay, unless and until it is not giving the attention to this word, how it will identify whether this 8 is represents the animal or not. Okay, now you can ask me how it is identifying whether it has to give the more weightage to these words or not. Okay, so for this we'll be understanding the self attention in detail. So here you can see he has given one example. Let's say this is your input. Input means your two words, thinking and machine. So the first thing what you have to do, you have to convert them to the embedding representation. That means the vector representation. Then what will happen, your transformer will generate actually 3 weights. Okay, you can see it will generate 3 weights, W, okay, WQ, WK and WV. And how weight initialization happens, I think you know. Okay, there are different techniques for the weight initialization, and these weights would be updated during back propagation. Okay, BP. I think you already know about artificial neural network. Okay, how it got trained usually, right? How it do the back propagation and all. This is like very basic concept. I'm expecting you are familiar with already, right? So these are the weight would be initialized at the very first, and this weight should be updated during back propagation technique. Okay, now you can see it is generating some more actually vector. The first vector it is generating queries, keys and values. Okay, now you can ask me how it is generating these are the values. See, first of all, what it will do, it will take this particular x1. Okay, it will take this particular x1 and it will multiply with the WQ. Okay, it will multiply with the WQ. So it will return you Q1. Okay, then it will take the x2. It will multiply with the WQ. It will return Q2. Okay, so that's how actually we'll be getting something called query vector. Okay, query vector. Then again, it will multiply x1 with WK. Okay, and it will return you K1. Then it will multiply x2 with WK, it will return you K2. So here you will be getting keys vector. Okay, then you will be multiplying this x1 with WV and it will return you V1. Then x2 with WV, it will return you V2. Okay, so that's how you'll be getting values vector. Okay, so that's how this three vector would be generated: queries, keys, and values. Okay, I hope it is clear now. Okay, now let me clear all the line here. Yeah. Now let's see the next actually mechanism. See, I think you got it. That means we are having our input data. That means input word, thinking, and machine. And first of all, we have to generate the embeddings. Then after that, with the help of x1 and x2, that means this vector, we are generating queries, keys, and values. Okay. And how? I think you got it. The multiplication actually strategy. Now the thing is like it will generate one score. Okay. How it will generate the score? See, to generate this code, it will use this q1. Okay, q1 vector, and it will multiply with the k1. Okay, that means q1 will multiply with the k1. Okay, this vector, that means keys vector. Query will multiply with the keys. Okay, and you will get one score. Let's say as of now, this is the assumption score he has given here, 112. Fine. Then for the next word, you can see it will multiply q1 with k2. Okay, q1 with k2, and here the score, let's say 96. Okay, now from this score you can see it is giving more score to the thinking word. Okay, to the thinking word than the machine word. Okay, that means it will more refer this thinking word. It will more give the attention to the thinking word. Okay, and that's how actually it is calculating this particular score. I think you saw this graph now. So how it is giving the attention to the word. Okay, that's how actually it is calculating. Okay, with the help of this particular vector calculation, it is creating this score, and based on the score value, it is giving the attention to that specific word. Let's say we are having two words, thinking and machine, so it will give the more attention to the thinking word. Now see, after getting this code, what it will perform? It will perform this softmax operation. Now see, what will happen? You are getting this code. Now this score would be divided by 8. Okay, that means you will divide this score by 8. Now if you divide this number, you will get 14, and if you divide this number, okay, you will get 12. Now we'll just calculate the softmax. Okay, I think you know the softmax. Okay, softmax is an activation function. It's an equation of the probability score, and if you just add this probability score, you will see that it would be 100% probability. Okay, always. So here you are getting actually 88%, and here you are getting only 12%. That means it is giving more attention to the thinking word. That means 88% attention it is giving to the thinking word, and only 12% attention it is giving to the machine word. Now I think it is clear how it is giving the attention to a specific word. Now in the 6th step, what will happen? See, I think you saw we are getting the softmax output. Now with this softmax output, what it will do, it will try to multiply this value. That means the value I think you are getting, remember this particular value. So it would be multiplied, and after multiplying, you will get one vector called v1, and again it will perform for the next word as well. So here you will get v2. Now let's see, you are having multiple word. So for all the words actually it will do the multiplication with the value. So here he only used 2 words, but you can consider more than 2 words as well. Okay, the working mechanism will remain same. Then after getting this v1 and v2, what it will apply? It will apply the summation operation. That means it will sum up these 2 vector, and you will get z1 and z2. Okay, and now I think you remember what is this z1 and z2. So let me show you that high level architecture. Here, see, this is the z1 and z2. That means this z1 and z2 is the output from the self attention. Okay, self attention layer. And how self attention is working as of now, whatever discussion I have given you, whatever, let's say, operation I showed you, this is the work of self attention, and that's how actually it will perform all the mathematical operation, and it will return z1 and z2, and this z1 and z2 will pass to the next, okay, next layer. Okay, next layer means I think this layer, yeah, to the feed-forward neural network. Okay, this is the idea. Now whatever I have discussed so far, if you want to see as a matrix representation, see the same thing. That means you are getting your input. Okay, you are getting your input. That means here we are giving our input. It will first of all convert it to the vector representation. Then it is generating some weights. Okay, WQ, WK, and WV, I think, remember. Then we are getting query, keys, and values. Okay, then it was multiplying this query with keys. Okay, and we are dividing with 8. Okay, and we are calculating the softmax. Okay, and softmax. And after that, whatever softmax output we are getting, we are performing the addition operation with the values. Okay, and it will give me Z. Okay, Z. That means the output. Now so far whatever actually operation you saw, this is for actually single head attention. Okay, single head attention. That means only one self attention. Okay, only one self attention mechanism. Now inside transformer architecture, they're using something called multi-head attention. You can see. So here is the term called multi-head attention. So what is multi-head attention? See, if I show you this graph again, see, if I'm considering it, that means it is giving attention to the animal did. Okay, these are the word. Even you can see it is also giving some attention to this word as well. But see, this thickness is like very, I mean, less here, because it is not able to give the proper attention to this word. Okay, because it is using only single head attention. Okay, and it is only using this 3 weight. Okay, this 3 weight is not enough. Let's say you are having huge amount of data, your input length is very big. That time actually only this 3 weight is not actually enough. So for this, actually what we have to do, we have to apply something called multiple actually weights. Okay, and if I want to apply multiple weights, so what we have to do, we have to use something called multi-head attention. So Google introduced actually multi-head attention. So they're telling, instead of only using one head, okay, one head attention, so they're telling instead of using only single head attention, we'll be using multi-head attention to perform the same operation. That means what will happen, see, this is the attention head 1, that means single head attention, and you will be taking another attention head. Okay, so this is called attention head 1. That's how we'll be taking another attention. And how many attention head it will be taking, I'll tell you. As of now, let's try to consider we are having multi-head, that means only 2 head. Okay, 0 and 1. Now the same thing they are doing, that means they're generating these weights. Okay, also this side also they are generating the weights, and the same operation would be happening as here as well. That means the operation I showed you now previously, the same operation will be happening here as well. Now you can ask me, what is the main objective to perform this multi-head attention? Because if you see in the transformer architecture, we can give very big size input. Let's say my input prompt would be very big. I think you saw in the ChatGPT, we can pass a very bigger prompt. Okay, very bigger prompt to the this one, our ChatGPT input, right? That means to my GPT model. So how it is processing that particular bigger input? Because it is using this multi-head attention concept. That means with the help of multi-head attention concept, it is able to give the attention to all the specific word actually present in that particular prompt. Okay, so this is the main idea. That means if you're only using single head, it won't be able to handle that particular bigger prompt. That's why you have to use multi-head attention here. Okay, always this is the main concept. Now see, that's how actually things are working. Let's say you are passing 2 words, thinking and machine. So you are passing as a vector representation. So this vector will go to the different attention. And now here you can see they're using 8 different attention heads. 8 different attention heads. That means whatever things we have learned so far, we have learned for only one self head attention, right? Well, self attention. Okay, but they're using something called 8 different self attention. 8 different self attention. Here you can see. Okay, attention head 0, 1, ... 7. Because it is starting from 0, that's why it is ending till 10. Now if you count it, they are using something called 8 different attention head here. Okay, so inside 8 different attention, all the calculation is happening. After that, whatever Z0, Z1, Z3 they are getting, they are doing the summation operation. Okay, and this is your final vector. Okay, this is your final vector. That means the Z. That means this one. Let me show you. This one. Okay, now inside that they're using 8 different self attention, and this is the Z1 output you are getting. Okay, I hope you got it. Now see how beautifully Jay Alamar created this blog, how beautifully he has used all the visualization. Okay, so to explain this particular concept. So that's why I feel like this is the best resources for the transformer. Okay, if you want to understand, you can use this particular blog. Now I think we have understood till here. That means we are getting the Z. Now see, if you see the entire architecture, that's how it is working. So you are having the input, you are it is initializing the weights. Okay, so it is generating the weights for 8 different actually self attention. Okay, then you can see the query keys values, then the Z. Okay, that means the output from my self head attention. Then it is concatenating all the vector, and we are getting only one vector, which is nothing but Z. Now see, after using multi-head attention, that is how your output looks like. Now see, it is able to give the attention to all of the word actually it needs. Okay, to represent this particular it right now. Now see, this line is more darker right now. Okay, this line is more darker. That means it is performing better than previous. That means previous we are using only one head attention. Now we are using multi-head attention, and the performance is very good right now. Okay, this is the main idea. Now see, he has captured some of the images. Okay, experimental images you can see here. Now let's try to understand another important things. I told you now. So let's say whenever we are using any, let's say traditional embedding model, let's say TF-IDF, Word2Vec, or let's say any other embedding model, let's say this one, bag of word. So it won't be able to capture the semantic meaning. Okay, semantic meaning of a sentence. Let's say here we are having a sentence. This is the, let's say, French sentence. Z Swiss A to the end. I don't know how to spell, but let's say this is my sentence. Now after Z, this particular word is coming. After this word is coming. Okay, how it will remember? That means how it will understand the contextual meaning. That means the sequence meaning. Okay, sequence meaning of a sentence. So to understand that sequence actually meaning, they're using something called positional encoding. Okay, positional encoding. Now let's try to understand what is positional encoding. See, let's say this is my input, it is converting to the vector. Now you can see this particular vector they are adding with the positional encoding. Positional encoding is nothing but it's a vector only. Okay, it's a vector only. You can see T1, T2 and T3, and they're doing the addition operation. Okay, after that they are getting the embedding with the time signal. That means whenever we write any kinds of, let's say, sentence, let's say my name, okay, is Bappi. So it always follows one time sequence. Let's say my I have written at the time of T1, name I have written at the time of T2, is I have written at the time of T3, and Bappi T4. Okay, that's how it follows one sequence. Okay, so that's why text data can be also called as sequential data. Okay, it's a sequential data because it follows the time. Okay, so that's why they are telling embedding with the time signal. That means whatever input you have given, okay, whatever input you have given, it is having one time. Let's say T1, T2 and T3 and so on, right? So on. So with that they're adding this positional encoding. Now how this positional encoding helping us to identify whether after Z this word is coming, after Swiss this word is coming, because if you see positional encoding nothing but it's a vector. Okay, and after adding this vector with my embedding, so again we are getting another vector, yes or no? Okay, now if you calculate the distance, okay, between these three vectors, you will see that this vector and this vector would be closely together, because if you just do the subtraction, okay, if you just find the distance, you will see that you will get very less distance between these two vectors. Okay, and you will see that this vector and this vector distance would be more. Okay, because you can see the number. Okay, so that's how actually it is identifying after Z this particular word is coming, after this word is coming. Okay, based on this particular vector. Okay, that's how they're doing distance calculation, and they're trying to understand the sequence information of a sentence. Okay, let's say after my Bappi is coming, after my name is coming, after name is coming, after is Bappi is coming. Okay, I hope it is clear. So that's how they're handling this particular sequence. Okay, now I think you got it. Whenever we are passing any kinds of bigger prompt to the large language model, how it is identifying that particular contextual meaning, how it is remembering that particular sequence. Let's say after this sequence is coming. Now he has added some more graphs. So as of now, let's skip. Okay, it's not required. Okay, now the next thing we'll be discussing about the residual block. Those who have learned about like computer vision, so I think you learned one model called ResNet. Okay, so in ResNet also we had this kinds of architecture. Okay, I think you remember. So let's say here we are having different layer. Okay, different layer. Fine. And we also had something called residual block. So that's how actually it will look like. That means whatever input actually you give usually. So sometimes, let's say if this block is not working good, okay, let's say this block is not working good, not good, then what will happen? It will skip this block and this output will go to the next block. Okay, this is called actually skip connection. Okay, skip connection. Okay, and this is called actually residual block. So we already learned this residual block in our CNN architecture. So the same residual concept has also applied in this particular transformer architecture as well. So here we are also having residual connection. You can see, let's say this is the input we are giving. Okay, let's say if this particular self attention layer is not working good, what will happen? This input will go to the next, okay, next layer. Now they're also using something called add and normalization. And what is normalization? I think you know, with the help of normalization, we just bring our data distribution in a normal, okay, normal distribution. I think you remember, right? This is whatever weight actually we're having. So if you just visualize them, you will see it will be a normal distributed, okay, normal distributed output. So it helps us during back propagation whenever it will try to find the global minima. Okay, that time actually this concept helps a lot. Now you can see again we are having another residual block connection, skip connection. Okay, so that means if any of the layer is not working good, this will actually skip this part and it will go to the next, okay, next layer. So this is the idea of the residual connection, because it's a very huge layer. Because you can see this transformer architecture, it's a very huge layer. So sometimes, let's say if you are using any simple data, very simple data, say you don't need all the layer, you don't need all the layer to process your let's say input. So sometimes whenever you are having the simple data, it will go to some of the layer and it will perform better. Okay, that time actually it will skip. These are the, let's say, layer. Okay, so this is called actually skip connection and residual block. And if you want to see the normalization, how it is performing the normalization, so here you can see the normalization. So it will do the addition operation x and z, okay, z vector, and it will perform the normalization like that. Okay, then whatever output it is having, it will pass to the feed forward, and feed forward again will pass to the add normalization, and again it will pass to the next, okay, layer. This is the idea. Now here you can see the entire architecture, guys. So far whatever we have discussed, now he has given inside one block only. Now we are giving our input, we are adding the positional encoding, then self attention, then we are also adding something called add normalization, then it will pass to the feed forward, then add normalization again, then it will pass to the next encoder. Okay, and inside that we are also having some residual connection. Okay, then whatever output we are getting, okay, let's say whatever, let's say encoder we are using, like I think I showed 6 encoder layer we are using. So this output will go to the decoder. Okay, now see, directly it is going to the decoder layer. Now at the same time, this output is also going to the encoder and decoder attention. Now you can ask me, what is encoder and decoder attention? See, this is the same, whatever things we have learned, encoder and decoder, the same architecture they're using in this particular layer. Okay, that means whatever output you are getting, you are again passing to this particular encoder and decoder, and again it will process those are the input and it will pass to the next layer. Okay, so that's how actually your output is passing to the encoder and decoder as well as the decoder. And how many decoder we had? We had 6 decoder layer. Now let's try to see the decoder side. Now see, here we are passing the input. So this is the input we are passing to the encoder. Encoder will pass this output to the decoder. But before passing this output, it will add some vector. You can see K vector and V vector. Okay, it will first of all multiply, then it will pass to the decoder. Okay, and decoder will pass to the linear and softmax. That means it will apply the softmax function on top of it. Now one thing will happen, let's see, if you are doing actually language translation, so the input you are giving to the encoder, so this output actually you are passing to the decoder, and decoder will predict something. See, decoder will predict something, it will generate something. Let's say I, so you are giving French input and you are getting English output. Let's say Z means I, Swiss means am, and educant means student. Okay, so that means it is, first of all, see, if you see the first iteration, let me show you. It's an animation. If I show you the first iteration, see, this is the first iteration. First of all, it is predicting I. So this I, again, it is coming as an input to the decoder side. You can see I. Then it is predicting am. Again, this am will go to the input of the decoder side. Okay, then it will predict something called A. That means based on these two words, it is predicting the next word. Okay, based on this two word, it is predicting the next word. Okay, I already showed you now that LLM concept, like it will predict the next word always. Okay, that's how it is predicting the next word. Okay, unless and until it is having the EOS sign, that means end of the sentence. Okay, EOS. Okay, this is the tag, I think you know. Okay, what is EOS? And there is another one called SOS. Okay, start of the sentence and end of the sentence. Whenever it is getting the tag, that means this sentence is complete and it will stop the execution that time. Okay, so that's how your encoder and decoder is working. Okay, and inside encoder, whatever things we are having, I already explained. Inside decoder also, whatever things you have, I already explained. Okay, that's how it is actually building one amazing architecture called transformer. Okay, transformer, and that is why transformer is so powerful, because it is having so many components inside that. It is using something called multi-head attention. Okay, that is the main concept here. So this is the entire understanding, guys, and I hope, guys, you got the high level understanding of this transformer, like how it is working and what is the internal mechanism of the transformer. Now if I open the actual architecture in the paper, now I think you will get it. See, this is the encoder side. Okay, this is the encoder side, and now I think you know what is input embedding and what is the positional encoding, what is multi-head attention, what is add normalization, and what is these are the arrow. That means this is the skip connection residual block. Then feed forward again, add normalization, again you are passing to the multi-head attention, and you are also passing this in output to the decoder side. You can see this is the decoder side, and inside decoder we are having multi-head attention, again add normalization, multi-head attention, feed forward, okay, softmax, and so on. Okay, and whatever output you are getting, you are again passing this output to the input of the decoder input. Okay, this is the idea. Now I think this architecture is clear how they have developed. Okay, now you simply just try to go through this paper once, just try to read, or you can also read this particular blog. Okay, so it will give you the clear-cut idea about the transformer architecture. Okay, so this should be my suggestion, guys. Please go through one time this particular blog, just try to read everything. Okay, see the way actually he has written, if anyone is from college background, they will also be able to understand. Okay, that much easy it is. So yes, this is all about our transformer intuition. I hope you got it, how transformer is working. So based on this transformer, today's actually whatever large language model we are having, they have developed. Now in the next video, we'll be learning about like how ChatGPT got trained, because you can see ChatGPT. So ChatGPT is using one large language model called GPT. Okay, so we'll be understanding how ChatGPT actually they train, like what is the internal mechanism of the ChatGPT. Okay, we'll be discussing this part. So I think you are already familiar with ChatGPT, right? So ChatGPT is a product of OpenAI. So inside ChatGPT, we can pass any kinds of prompt and we can get the response. So it is kinds of conversational, let's say, chatbot they have developed. But by that particular chatbot, what you can do, you can perform all kinds of NLP tasks. I think I showed you one example. I think you remember. We can perform language translation, text summarization. We can also perform sentiment analysis. Okay. We can also, let's say, generate the codes. Everything is possible because I already told you, na, LLM, why it is powerful? Because it can perform multitask, right? Multiple tasks it can perform with the help of one model only. Task wise, it is clear like how it will able to perform that task, right? But what about the conversational agents? Let's say whenever I'm passing any kinds of prompt, how it is identifying, okay, how it is identifying what kinds of, let's say, prompt I'm giving and what kinds of tasks actually I'm expecting from my chat GPT. Okay, so this is what actually we'll be understanding in this particular video, because if this understanding is clear, so going forward, whatever model you'll be learning, whatever application you'll be building, this would be more clear in your mind. So first of all, you have to remember one thing. See, chat GPT is not a model. Okay, so ChatGPT is just an application. Internally, it is using a LLM, which is GPT 3.5 or GPT-4. It has trained on large amount of data, which is also available over the internet. That means over the internet till 2023, whatever actually data we are having. So all the data they have used to train this GPT-3 or GPT-4 model, right? Now to train this ChatGPT, they actually follow 3 steps. The first step is generative pre-training. The second step is supervised fine-tuning, and the third step is reinforcement learning. I'll discuss all of them one by one, no need to worry. But first of all, just try to see, as I already told you, ChatGPT is not a model. It's just an application. It's just an interface, right? So whenever you are giving any kinds of prompt to the ChatGPT, it is using one OpenAI API key, right? I think you know what is OpenAI API key. With the help of OpenAI API key, it is sending that particular request to the model. You can see it can access different model of the GPT, like GPT 3.5, GPT-4, okay, or any other model actually GPT is bringing in future, right? So this is the idea. Let's say you want to perform language translation. You are giving the prompt here. So this ChatGPT interface receiving your prompt, then it is sending that particular prompt to the model with the help of OpenAI API key. That is the idea. Okay, so that means ChatGPT is an application, and it is using internally it is using some kinds of LLM, which is known GPT-4 or GPT 3.5. Now, as I already told you, they used actually 3 steps to train this model. Now you can see the first stage is generative pre-training. So here you can see this base model GPT trained on a bunch of stuff from internet for a whole bunch of different things by using the transformer architecture. That means they're using a transformer architecture internally, and they're training on top of the internet data, okay, or internet documents data you can talk about. Then they are getting something called base GPT model. Okay, base GPT model. Then this base GPT model, then again they are doing something called supervised fine tuning. Okay, in this stage 2 they are doing supervised fine tuning. So what is supervised fine tuning? I'll discuss everything, no need to worry. So next, with the human AI trainers, you get to have conversation where they play both sides, you and AI assistant. Okay, now after performing the supervised fine tuning, they get one model called fine tune chat GPT model. Now they'll be performing something called reinforcement learning through human feedback. So here you can see next, let's take the model to the next level by optimizing its even more reinforcement learning by training it against a reward model. Okay, that means they will be creating something called reward model. And why they'll be creating the reward model, I'll tell you. Then after that, they will be getting the chat GPT model. And this is what actually we are using. Okay, this is what we are using in our day-to-day life. This is the idea. Now let's discuss all the stages one by one. Now, first of all, let's try to discuss generative pre-training. Okay. Now see, what is generative pre-training? As I already told you, they're using a bunch of data from the internet and they're training one transformer model. Okay, so they're using the code transformer architecture only. On top of that, they're adding some more layer. Okay, and they're creating one GPT model. Okay, this is called a GPT model. Now this model will be able to do actually various kinds of tasks like text summarization, sentiment analysis, sentence completion, translation, and so on. But what is our expectation from our chat GPT? So here user can pass any kinds of prompt. He or she can chat and conversation with this let's say application, yes or no, right? But after training this particular, let's say, transformer model, we are only getting the actually task output. Let's say this model only can perform text summarization, sentiment analysis, sentence completion, and language translation. Apart from that, actually, it can't do anything. Let's say it can't do the chat conversation with the human. Okay, this model can't do. So this is our expectation. Okay, with that, this is our expectation. So for this, actually what they did, actually they followed another stage called supervised fine tuning. In supervised fine tuning, what they have done, so they have actually taken two human. So one human called human agent acting like a bot, another human, the actual human agent. Okay, that means both are human, but one human actually will act like a bot and another human will act like a human only, right? So this particular human will give some request. Okay, let's say he will put some, let's say text, let's say how are you. So this human will give the reply, let's say I'm fine, what about you? Again he will give I am also fine. Then he will tell I need help from your side. This particular, let's say, human will tell, so this particular human will tell how I can help you. Okay, so that's how actually they will be doing the conversation, the way actually we do the conversation with our chat GPT. Okay, so initially we have to create our data, that means chat data. Okay, chat data. So to collect the chat data, they're using this particular technique called supervised fine tuning. Okay, supervised fine, they're supervising the model. Okay, this is the main idea. Now see, after doing these kinds of conversation, you will have different data. Let's say from the human side, you will get lots of requests, and from the bot side, that means human agent bot side, you will be getting lots of response. Now you'll be using this particular data to train again your base GPT model. Okay, you will be again fine tuning your base GPT model, and you will be using something called stochastic gradient descent optimizer. Okay, SGD optimizer they are using, and they're training one model called SFT chat GPT model, that means supervised fine tuning model. Okay, this is the main idea here, and this is called actually SFT and supervised fine tuning. But one issue actually they observed after doing the supervised fine tuning, this model can only perform related to the training data. Let's say if someone is giving any kinds of input which was not present in the training example, at that time this model was giving some random output. Okay, so to actually overcome this issue and to make this particular model more good, they followed something called reinforcement learning through human feedback technique. So inside reinforcement learning through human feedback, what they are doing, whatever, let's say, conversation having between this human agent and SFT chat GPT model, so they're trying to rank the results. Okay, rank the response. You can see, let's say this SFT model will give actually multiple response. Now there would be a human. Okay, there would be a human agent. So this human agent will rank the result. Let's say here we are getting 1, 2, 3, 4 different response. Let's say A, B, C, and D. Now between these 4 results, which one is the good? Okay, which one is the good and which one is the, let's say, suitable with the user input user has given. Now he will just try to rank the results. Now let's say B response is good, then A, then D, then C. Okay, this is the rank response. That's how actually he will try to prepare. Then what they have done, they created one reward model. And what is reward model? Reward model is nothing but it's a reinforcement learning model. Those who are familiar with reinforcement learning, I think you know what is reward model. So here you can see they're giving actually different response, and they're actually generating one score. Okay, like what is the score for this response? What is the score for this response? Okay, that's how they're generating the score. Now whoever actually having like more score, this particular response would be considered as my final output. Okay, that's how actually they're doing reinforcement learning through human feedback, and they're improving the accuracy of the model. This is the main idea. That means if you see in high level, so you are using reward model and you are ranking this particular, let's say, response. Based on that based on that actually you are providing the actual response, and this reward model will give some policy. Let's say if this response is good, if user is liking that particular response, so definitely it will give some reward, otherwise it won't be giving any kinds of reward. So sometimes in the chat GPT will see that it will ask for your feedback, whether you are getting the correct output or not. If you give the, let's say, low rating, that time they will consider this model is not working good, that time they will give negative reward. So again this reinforcement learning will automatically learn, okay, how to improve the quality of the model. And if you are giving positive feedback, that means it will give the positive reward that time. Okay, so that is how actually reinforcement learning works. So here in the environment, you just put one agents, that particular agents learn the environment, and whatever activity you are doing, it will try to learn, and based on that it will try to update the reward model. This is the main idea, right? So yes, this was the actually core concept to train this chat GPT model. And that's how actually not only we get that task specific model, we can also perform the conversation with that particular model. Okay, because they have done, because I think I showed you now how they have done this particular entire strategy and how we can perform the conversation. So whenever we are giving any kinds of prompt, first of all, it will try to understand my prompt because of that particular supervised fine tuning. Let's say I'm giving a prompt, I want to do the language translation French to English. So it will try to understand that particular prompt. Then based on that, it will decide what kinds of tasks you want to perform. Okay, apart from that, if you are doing some casual conversation also, it can also handle, because again it was trained with huge amount of data. Okay, that's the idea. So yes guys, I hope this makes sense now and you got how ChatGPT was trained. And now this concept will help you to understand whatever, let's say, model will be understanding in future. Okay, so I think you enjoyed. So if you don't know about Hugging Face is a platform. So with the help of this platform, you can do generative AI project, you can do NLP project, even you can also perform computer vision related project. So here we are more focusing on the generative AI. So we'll be using this Hugging Face platform for the generative AI related task. So this Hugging Face platform is having all kinds of large language model. Even it is also having so many datasets you can use to train these kinds of large language model. And Hugging Face provides one pipeline. So with the help of this pipeline, you can easily perform any kinds of task. And Hugging Face is also having one Python library called Transformer. With the help of Transformer library, you can easily implement any kinds of generative AI based project. So let me show you this Hugging Face platform. What are the things it is having? So guys, if you want to open the Hugging Face platform, just search for Hugging Face. Okay, Hugging Face in Google. You will see this first link. Just try to open it up and make sure you create one account here. So for me, I already have one account. So what I will do, I'll just try to log in with my account. So if you don't have the account, you just need to do the sign up operation. Okay, so with your email address, you can also create an account. So let me log in with my account. So guys, as you can see, I already logged in with my account and this is the interface of the Hugging Face. Now, as I already told you, Hugging Face is a platform. So with this platform, you can perform lots of tasks. You can perform generative AI related tasks. You can perform natural language processing related tasks. Even you can also perform computer vision related tasks. Okay, even you can also do audios kinds of tasks. Let's say you are having audio data. Okay, you can also do these kinds of tasks in this Hugging Face platform. Okay, now it is having actually different services. The very popular services it is having called models. That means this Hugging Face is having all kinds of large language model. Let me show you. If I click on the model section, now see, it is having that many of model. Just try to see the count. That many of models are available, and these are the models are completely open source. So you don't need to pay here. Okay, if you want to use these are the model, you don't need to pay here. Only you just need to use Hugging Face Python library for this. Okay, with the help of Hugging Face Python library, you can easily access these are the model. Even I will also tell you how we can access different open source large language model and how we can implement different application on top of it, right? Now, if you see left hand side, it is having different tasks. You can select the multi-model. That means if you want to generate image text to text, if you want to do visual question answering, if you want to do, let's say, document question answering, if you want to, let's say, do video text to text, everything you can perform here. Then it is having computer vision related tasks. You can perform object detection, image classification, image segmentation, text to image. Okay, all kinds of computer vision related tasks are available. Even nowadays, whatever multi-model you can see, let's say large language model will generate image, large language model will generate videos. These kinds of models are also available in this Hugging Face platform. Now you can see it is also having natural language processing related tasks. That means you can perform text classification, token classification, summarization, feature extraction, text generation, code generation, everything you can perform here. Okay, apart from that, I already told you it is also having some audios model. Let's say you want to perform text to speech, text to audio, okay, automatic speech recognition. These are the tasks also you can perform here. Apart from that, it also provides tabular kinds of tasks. Let's say you can perform tabular classification, tabular regression, time series forecasting. These are the tasks you can also perform. Then they have added another amazing technology, the reinforcement learning. So those who are interested in reinforcement learning, you can also perform reinforcement learning operation with the help of Hugging Face platform. So it is having all kinds of reinforcement learning model. You can also perform something called graph machine learning with this Hugging Face platform. So here I'm not going to focus on all the actually task here because we are more focusing on the generative AI, and for generative AI actually we'll be more focusing on the NLP, that means natural language processing, and we'll be focusing on the multi-model section. Okay, because it is having different large language model, as I already told you. Now you can select any kinds of task. Let's say you want to perform, let's say this one, you want to perform, let's say a text classification. Okay, just select the text classification. Now see, automatically it will suggest you all the text classification related model. Now see, these are the model from different organizations. See, this model is from Meta AI. Okay, Meta Llama. See, with the help of Meta Llama, you can also do text classification, and this is one of the large language model. It is having 86 million parameter, and this is the download. See, this is that many times actually this model got downloaded. Okay, so you can also download this model if you are let's say you like this model, you can also start this, you can also like this. Even they have already given the model card. Let's say you want to read about this model, like what this model can perform, how many parameters it is having, what kinds of data it got trained. Okay, everything they have given. Okay, everything they have given. Even they have also given the code snippet you can use. Okay, let's say you want to test this model, you can copy this code snippet and you can execute it here. Okay, so it's one of the amazing platform, guys. If you are working in the field of generative AI, so definitely you should learn the Hugging Face platform. And no need to worry, everything I'm going to teach you here. So let me show you what are the things we'll be discussing here. See, inside Hugging Face, actually, Hugging Face, we have to learn some of the very important concept. The first concept, we have to learn the pipeline, because inside Hugging Face, everything is all about pipeline. Okay, whenever you will be using one Python library of the Hugging Face called transformer. Okay, transformers. See, transformers is the architecture, but they have also named it as a library. Okay, because it is having all the model which is based on the transformer architecture only. So that's why they named this particular library as a transformer library. Okay, so inside transformer library, whenever you will be writing the code, let's say you want to perform language translation, summarization, you have to create a pipeline for this. Okay, so we have to discuss the pipeline. Then we'll be discussing different NLP tasks you can perform with the help of this Hugging Face library. Then we'll be discussing very important concept called tokenization. Okay, because in Hugging Face, everything is all about tokenization. So whatever pre-processing, whatever text representation you have to do with the help of tokenization only. Then we'll be discussing about the dataset, like what are the dataset it is having. Then we'll be also discussing about another super important service called Spaces. Let's say you don't have good configuration PC, but you want to train one large language model. So what you can do, you can also take the Hugging Face Spaces. That means Hugging Face infrastructure. But definitely you have to pay for this. So there actually you can train any kinds of large language model. Okay, and this machine is like very good configuration machine you can take there. Then the fifth topic we'll be discussing about fine tuning. Okay, fine tuning LLM. Okay, with the help of Hugging Face. That means we'll be learning how we can fine tune any kinds of LLM. Okay, with the help of Hugging Face platform. Then at the last we'll be seeing some of the project implementation. Okay. So with the help of Hugging Face, we'll be doing some of the project implementation. That means we'll be doing text summarization, language translation. Even we'll be also doing the research paper summarization. So these are the project we'll be implementing one by one. So I hope this is enough to know about Hugging Face. And if you understand these are the concept, definitely you can use Hugging Face platform if you want to build any kinds of application, okay, later on. And trust me, guys, if you want to use open source large language model, that means Open LLM, okay, Open LLM. So Hugging Face is the only way, okay, you can use Open LLM. Okay, Hugging Face is the only platform. It will help you to work with the open source large language model. But if you want to work with paid large language model, let's say if I want to take any kinds of commercial large language model, that time you can use something called OpenAI. Okay, OpenAI platform. Even there are some cloud platform as well. Let's say Bedrock is there. Okay, Amazon Bedrock is there. Then Vertex AI is also there. So we'll be also learning these are the things one by one, no need to worry. First of all, let's try to understand the Hugging Face, because this is the starting point. Okay, this is the starting point in the field of generative AI. So what I feel like, if you want to understand the generative AI, if you want to understand the large language model, if you want to, let's say, use them as a practical, so I will suggest first of all start with Hugging Face platform, then try to learn OpenAI and whatever services you are having. Okay, everything I'm going to teach you, no need to worry. Okay, so apart from that, it is also having data sets, guys. As you can see, different data sets. Let's say you want to train one language translation model. So simply you can select the task here. Let's say I want to do the language translation. I'll select the task here. So this is the translation. Now see, these are the data related language translation. Okay, see, these are the data related language translation. So it is having all kinds of language translation data, you can see. So see, this dataset is containing Canadian actually text as well as the English text. That means you can perform Canadian to English, otherwise English to Canadian, I think. Okay. Apart from that, you are having different dataset. Even you can also search here. If you want to, let's say, find any kinds of dataset, you can also search here. It is also possible. Now, apart from that, you can also select different libraries. Let's say I want to perform one task. Let's say I want to find a model. Let's say I want to perform something called text classification. Now I want to use one specific library. So see, it is having different library. You can use PyTorch, then you can use TensorFlow, then you have Safe Tensors. Okay, then you are having Keras, different library it supports. Let's say I want to perform with the help of PyTorch. Okay, PyTorch framework. So these are the model related PyTorch. So if you want to use these are the model, you have to use PyTorch code. So similar wise, if you want to perform with the help of, let's say, TensorFlow, you can select the TensorFlow. It will give you all the model related TensorFlow that time. Okay, that time you have to install TensorFlow library. Okay, not the PyTorch library. So that's how it has given different flexibility, different functionality, so that you can filter out the specific model, filter out the specific data. Okay, everything you can do here. And it is having another amazing service, as I already told you, the Spaces. So Spaces will give you, let's say, this infrastructure. If you want to train any kinds of large language model, you can use their Spaces service. So there you can buy their instance and you can train your model. See, it is having different spaces. Even you can also create your own spaces. Now, apart from that, it is having another amazing documentation. Now, see, if you want to deep dive in this Hugging Face platform, like how you can use this Hugging Face platform properly. So they are also having their official tutorials. If you just go to the documentation, so they are having one documentation, and inside that you will get one section called task. Now let's click on the task. Now see, let's say I want to perform image classification task. So I'll just simply click here. Now see, it will give me the official tutorial. So they have their also YouTube videos. You can also refer the YouTube videos. Even you can also refer their blog. Okay, how we can perform the text classification that time. Sorry, how we can perform the image classification. So everything they have written here. Okay, so this is one of the amazing, actually, let's say, platform I personally prefer if I want to implement any kinds of project, and if I want to learn anything. Let's say I don't know about, let's say, zero-shot image classification. I'll come here. I'll go to the tutorial section, and easily I can learn, okay, how we can use this particular model. Okay, so that's how actually you can also deep dive. But if you cover this video, I hope you will be learning everything about this Hugging Face platform. But still, if you want to deep dive, you can refer their tutorial as well. Fine. And if you want to take the premium subscription, you can also see their pricing and all. You can also check it up. But as of now, premium subscription is not required. We'll be using free services. Okay, free services is enough for us, because here we'll be only accessing the models dataset. Okay, these are the thing. As of now, I'm not going to take the Spaces. Everything I'll be doing in my Google Colab, because in Google Colab we'll be getting free GPUs. Okay, that is the idea. So yes, guys, this is the introduction of the Hugging Face. Now I think you got it, what exactly this Hugging Face is, and we saw like different services of the Hugging Face. Now in the next video, we'll be doing some hands-on on top of the Hugging Face, like how we can use the Hugging Face with the help of Python programming. So there we'll be installing one amazing library called Transformer. Okay, with the help of Transformer, we'll be using the Hugging Face. And it is also give you the API functionality, guys. If you want to take the Hugging Face API key, you can also take. For this, you have to go to the settings. Now here you are having something called access token. Okay, you can also take the access token. So with the help of access token also, we can access the model. Let's say some of the models you will be getting here, those models actually you can't directly download. For this, you need this Hugging Face access token. Okay, so we'll be also learning how we can use the access token to access any kinds of model, and how we can generate these are the access token as well. Fine. So here I already created one Colab notebook, and here I have already mentioned each and everything you need for the Hugging Face. Okay, practical understanding. So as I already told you, if I want to use Hugging Face platform with the help of Python, we need to install one library called Transformers. Okay, so this is the library. So Transformers library is having all the functionality present inside the Hugging Face platform, right? So if you want to install Transformer library, so you have to execute this command called pip install Transformers. Okay, now let me first of all connect this notebook, and the resources would be shared, guys, in the resources section. So from there you can download, and you can also code with me. Okay, it is connected now. Now the first thing what you have to do, you have to select the runtime to GPU. Okay, because I'm not going to use the CPU configuration machine here. I'll be taking the GPU machine, because here we'll be using large language model. So definitely you have to select the GPU based machine there. Fine. So let me select the GPU machine. And if you're using free Colab, you'll be getting T4 GPU. And if you're using Colab Pro, there also you can take actually different. See, let me show you. If I click on change runtime, see, you can also take A100 GPU and L4 GPU as well. Okay, these are the GPU you can also access. So now, guys, you can see my notebook is connected. Now, if I want to check the GPU, you can execute this command called NVIDIA, okay, -SMI. So this will show you the GPU configuration you got. So here I'm using free Colab, that's why I got Tesla T4 GPU. Now, first of all, I have to install the Transformer library here. See, Transformer is already installed. Now, see, inside Hugging Face, we are having different tasks, as I already showed you. So if I, let's say, click on the models, and if you see the left hand side, you can see you are having different tasks. So here you are having different tasks. Let's say here we are focusing on generative AI, that means the natural language processing. So here we can perform different tasks. Let's say we can perform text classification, token classification. Okay, all kinds of tasks actually you can perform. Whatever tasks actually you see in the field of NLP or in the field of, let's say, generative AI, all kinds of tasks you can perform here. So if I want to perform these are the tasks, I have to use one functionality from the Hugging Face called pipeline. Okay, so here you can see I have imported this pipeline from the transformer. Okay, so it is available inside transformer. Now let's say we are having various NLP tasks, as I already showed you, text classification. Then we are having here you can see text classification, token classification, table question answering, zero shot classification, translation. Okay, now see I have listed down all the tasks here. Now let's say if I want to perform text classification, so what you have to do inside pipeline, you have to mention I want to perform text classification. So this transformer library, what it will do, it will automatically try to understand you want to perform text classification. So all the code actually it is having in the backend, it will execute that particular code snippet. That means it's a high level wrapper. Okay, on top of, let's say, Hugging Face, it's a high level wrapper, this particular transformer library. So you don't need to write the code from scratch. Let's say you don't need to write the code, I want to perform text classification. So code you don't need to write from scratch. Only you just need to give this particular input to the pipeline, and pipeline will automatically take care. You have to do the text classification task. And for this, whatever, let's say, strategy you have to follow, everything, it will take care. Okay, I hope you got it. Now see, similar wise, if you want to perform token classification, you can mention token classification. If you want to perform question answer, you can also give question answering. If you want to perform text generation, summarization, translation, even also you can select the model. Let's say which model you want to use. As I already showed you, now we are having so many model. Now let's say I want to perform translation. Now see, you are having different model. Okay, different model. Now see, you can also give the model. Okay, model ID. Now let's say I want to use this model. I'll just click here and I'll copy the model ID. This is the model I'll copy, and here I just need to mention. So it will automatically download this model from the Hugging Face. So you don't need to manually download it as well. So that much powerful it is. Okay, so that is why I told you you have to master this pipeline concept, because going forward, whatever actually, let's say, application you'll be implementing, you need this particular pipeline approach. Fine. Now see, I have given different actually example, a computer vision example also. Let's say you want to perform image classification in the pipeline, just mention image classification. Okay, even also you can specify the model. It's up to you. Now see, different example I have given just for your reference, so that you can refer this notebook later on. Now let's perform one specific NLP task. Let's say I want to perform sentiment analysis. So here you can see the task, as well as you will also get the all kinds of tasks in the documentation section. So here you are having one tab called task. Now see, all the task is also visible. Read that, computer vision, natural language processing, audios, and multi-model. Okay, everything is there. Now let's say I want to perform sentiment analysis, and sentiment analysis is what kinds of task? It's a text classification task. I think you saw it's a text classification task. Okay, now either you can give the text classification. Okay, either you can pass the text classification